Sì, va bene, va
Va
bene.
congelato.
Sì, sa. Ok.
Va bene, va bene.
Cioè,
Benissimo, buongiorno a tutti, benvenuti a questo talk. Sono contento di vedere tutte queste persone qui interessate a Python perché lo sentiamo dentro il nostro linguaggio, il nostro framework, è quello che facciamo ogni giorno. Abbiamo qui oggi Raffaele Colace, che riprendendo un po' quello che abbiamo sentito all'opening, no? La scenetta è stata fatta dell'aereo, no? delle procedure di sicurezza. Ecco. Un aereo deve volare bene e per questo aereo farlo volare bene è bene fare i test. No? Ci sono delle procedure specifiche e ben precise, no? Nell'ingegneria aeronautica che vengono fatte. Ecco, anche per l'ingegneria del software vale lo stesso discorso, altrimenti il nostro software cade giù, che non è il massimo. Quindi ora lascio la parola sicuramente a Raffaele, che ci darà la possibilità di approfondire questo tipo di argomento. Buon lavoro. Un applauso.
Grazie Salvo. Bene, io sono felice di fare questo talk anche perché è arrivata la comunicazione, insomma, cotta e mangiata, e quindi anche quest'anno in un modo o nell'altro mi trovo qui. Chi di voi conosce questo aereo? Parlavamo di aerei. Qualcuno di voi l'ha mai preso? Marco, quindi se vi dicessi che il software di pilotaggio potrebbe avere un bug, vi sentireste sicuri a prenderlo? Esattamente. Oppure se vi trovate sotto i ferri e il sistema di monitoraggio durante l'operazione, diciamo a cuore aperto, crasha. Come vi sentite? L'ansia sale? No? Io sono Raffaele Colace, come diceva Salvo, sono uno dei fondatori di Ventitab, è un'azienda che sviluppa e gestisce progetti utilizzando per lo più Python lato backend, e poi utilizziamo approcci agili, lean, eccetera, eccetera. Sono un appassionato come dicevo, di Agile, e sono il fondatore della prima conferenza italiana dove si parla di product management, che si terrà a novembre quest'anno. Chi se ne frega. Di che parliamo oggi? Intanto vediamo qual è il contesto in cui ci troviamo, quindi il mondo dello sviluppo del software e cosa succede là fuori. Parleremo un po' di come migliorare questo ecosistema, parlando quindi di qualità del codice. E poi faremo un esempio molto molto basic, perché insomma è a fini come dire, didattici, no? Quanti di voi scrivono i test tutti i giorni? E che ci fate in questo talk? Vabbè. Benvenuti comunque, insomma. Dicevamo, il 737 MAX. Questo aereo aveva un bug nel sistema di autopilotaggio. In realtà c'è un mondo dietro a questa storia, anche negligenza nel documentare le funzionalità. Insomma, i piloti non erano messi neanche nelle condizioni di disabilitare queste funzionalità. E quello che è successo è che in 2 voli distinti l'aereo, subito dopo il decollo, diciamo, il software ha pensato che stava in stallo e ha tentato di portare l'aereo in volo, però sbagliando, portandolo in picchiata. E subito dopo, insomma, questo errore ha causato la morte di 346 persone. Ricordatevelo il numero perché è interessante. 346 persone. Tutti i dettagli di questo tema lo trovate su questo talk di Nicholas Mintz. Ovviamente non entrerò nei dettagli perché non è lo scopo di questo talk, no? Però vi consiglio di dare un'occhiata perché è molto interessante. Prima parlavamo anche dell'ambito medicale. Uno dei più gravi bug della storia è legato al Terec 25, che somministrava radiazioni diciamo, durante la radioterapia. E un semplicissimo bug ha fatto sì che somministrasse 100 volte le radiazioni necessarie, causando l'avvelenamento di 6 pazienti e la morte di 3. Quindi un programmatore non si è preoccupato di risolvere il bug e 3 persone sono morte. Così. non voglio, come dire, non voglio creare disagio, ma un altro bug, insomma, interessante è quello dell'Ariane 5 che per una conversione sbagliata è esploso dopo 37 secondi dal lancio. Ragazzi, 37 secondi, ci avranno messo anni a costruire tutta sta roba e 37 secondi, puff, bello, bravi. Questo qui è il Mars Climate Orbiter, avrebbe dovuto prendere i dati su Marte. Hanno detto vai, entra nell'orbita. Peccato però che anche qui hanno sbagliato la conversione dei dati e quello se n'è andato, cioè se n'è andato alla deriva. Chissà che dati ha preso, ma non li ha mai mandati a noi di fatto. Anche qui il numero è interessante, si parla di 327,6, leggo perché non me li ricordo tutti questi numeri, milioni di dollari tra in tutte le operazioni, lancio, costruzione, eccetera. 327 milioni di dollari stavano molto meglio in tasca mia. Questo lo conoscete tutti ovviamente. Qui i danni credo siano incalcolabili perché sono stati trafugati dati ovunque, quindi è difficile dire con quei dati che cosa è successo, no? È stato bucato OpenSSL. Boh, se qualcuno ha il dato me lo dica perché sono curioso. Oppure vabbè, Facebook, Instagram, quante volte è andato giù? Una volta è andato giù perché hanno configurato male il DNS. Ad un certo punto Facebook è sparito da internet. Cioè non c'era su internet, non c'era Facebook. Quindi gli omini sono andati lì fisicamente a riconfigurare il DNS perché non rispondeva. Questo ho bisogno di citarlo? No, non lo citiamo perché non è interessante. Però insomma lo cito invece, perché durante il Covid tutti quanti siamo stati lì a cliccare, no? A cliccare e a imprecare successivamente. Questo non è ancora accaduto, almeno non a me, però me lo sono immaginato. Che cosa succede se domani per un'ora spariscono quei due pulsanti? Che succede? Vediamo. Allora, Amazon fattura circa 1,29 miliardi di dollari al giorno tra tutte le cose che fa, diciamo. No? Io per approssimazione metto quel numero, va bene così. Diciamo che non sono 1,29 ma 1, poco cambia. Circa 53 milioni all'ora. Facciamo finta che quel bug sui pulsanti dura per un'ora, una sola ora. Io ho chiesto a Midjourney come potrebbe essere la faccia di Jeff Bezos, no? E me l'ha disegnata così. Allora, con quella cifra Jeff Bezos si compra un paio di scarpe, esatto, però mi piaceva l'idea di... Io mi sentirei così. Qual è il contesto? Questa slide racconta di uno studio fatto nel 2020 solo negli Stati Uniti, quindi anche un po' vecchiotto, dovrei riaggiornarla, però mi hanno chiamato l'altro ieri per questo talk, quindi 2 trilioni di dollari sono stati spesi in software di scarsa qualità e 1,31 trilioni di dollari per debito tecnico. Questa cifra a casa mia si traduce in circa, in difetto, 3 trilioni di dollari. E se faccio due banalissimi conti della serva per quanto tempo ho lavorato nell'ambito dell'IT, qui mancano un paio d'anni, io faccio un calcolo veloce, ho visto bruciare circa 60, perché mancano un paio d'anni, trilioni di dollari in software di scarsa qualità o debito tecnico. Con questa cifra mi ci compro la Sardegna probabilmente, non lo so, quanto costa la Sardegna? Di più? Pure la Corsica? Ah, ok. Vabbè, mi compro un po' di roba, no? Sempre che stavano bene in tasca mia, questi soldi, però vabbè, è andata così. E questo è successo solo in America, e solo nel 2020 3 trilioni, quindi, cioè, calcoliamo tutti i soldi che sono stati spesi in tutti gli altri continenti, no? Va bene, torniamo al titolo del talk. Il software funzionante è il principale metodo di misura di progresso. Intanto chi conosce questa frase? Chi l'ha mai letta da qualche parte? Nessuno? Bravissimo. È E quindi la domanda successiva che faccio è: chi conosce il manifesto agile? Allora dovete studiarlo un po' di più perché non conoscete uno dei 12 principi, che è esattamente il titolo del mio talk. Per chi non lo conoscesse, il manifesto agile diciamo, è un documento di dichiarazione di intenti di 17 illustri programmatori all'epoca, informatici comunque, e racconta 4 valori e 12 principi. Si legge in 10 minuti, si capisce in un paio di mesi, si applica in un 3, 4, 5 anni, insomma, ok? Con i vari framework che ci stanno in giro. Però è bene partire almeno dalla comprensione di questo testo. Quindi vi consiglio di andare a dare un'occhiata. Quando è che possiamo dire che il software è funzionante, però? Io mi faccio 3 domande, poi lascio a voi l'integrazione volendo, però intanto mi chiedo se questo software è dannoso. Quindi questo software che sto costruendo può creare dei danni a qualcuno, a un'azienda, a qualche persona, all'ambiente? Quindi se è dannoso in qualche sua forma, ovviamente il software non è funzionante. E quindi è la prima domanda alla quale voglio rispondere. La seconda è: contiene codice difettoso? Ed è una domanda che dobbiamo porci e dobbiamo rispondere con no. Se rispondiamo non lo so, non funziona, non va bene, ok? L'altra domanda è: riusciamo a verificare in modo ciclico che questo software è funzionante? E quindi per dire che non è dannoso e per dire che non c'è codice difettoso? Al momento queste sono le domande che mi pongo quando voglio arrivare in produzione, ok? Come dice... chi conosce questo tizio? Vedo pochissime mani alzate, sempre molto male, ok? Come dice questo tizio, che si chiama Uncle Bob per gli amici e Robert Martin per chi non lo conosce, non consegneremo mai più merda. Vorrei ripetere questa parola per il resto del mio talk perché ci starebbe, però eviterò. Dirò la parola con la M. Ma esattamente quando è che consegniamo software di parola con la M? Intanto quando rilasciamo un bug. Se stiamo rilasciando in produzione un bug, abbiamo rilasciato codice di scarsa qualità. Ok? Quando una funzione non è sottoposta a test, stiamo di fatto rilasciando codice di scarsa qualità. Quindi se lo stiamo facendo volontariamente, dobbiamo assumerci la responsabilità di questa cosa, no? Ogni funzione è scritta male, e qui c'è il mondo. Qui vi direi in modo creativo quale può essere una funzione scritta male. Ce ne stanno tanti modi, ho visto del codice molto molto fantasioso e creativo. Ogni accoppiamento non necessario, non farò tutta la lista perché sarebbe lunghissima, no? Quindi a voi la creatività di dire quando è che il software risponde, quello che rilasciamo risponde alla scarsa qualità, no? Possiamo approfondire volendo, ma non abbiamo troppo tempo. Ok, ma se sappiamo che questo avviene, perché continuiamo a farlo e anche in modo iterativo? Ci sono tanti motivi in realtà, no? Il primo sono le scadenze. Andava consegnato per ieri. Era quella la scadenza, no? Il cliente paga per avere software, non qualità. Oppure il capo. Ho venduto sta cosa, subito la dobbiamo produrre. Non si può fare. No, ma ormai l'ho venduta. Vabbè, cazzi tuoi direi io, però vabbè. Oppure abbiamo stimato male. Abbiamo stimato male e quindi siamo arrivati tardi, siamo andati lunghi e dobbiamo consegnare, ci vergogniamo della stima. A volte è noncuranza. Copiamo il codice su Stack Overflow oppure diciamo a Copilot di scriverlo per noi o ChatGPT, no? E non leggiamo quello che scrive. Sì, no, l'ha scritto Copilot, andrà bene. No, non va bene ragazzi, ve lo dico, l'ho provato, non va affatto bene. Disattenzione, molto spesso facciamo 100.000 cose, quindi quando fai 1000 task insieme qualcosa ti sfugge, no? E qui se avete altri motivi, insomma, ditemeli che li aggiungo alla slide, ma ce ne stanno veramente tanti. Comunque, qualsiasi sia il motivo che vi possa venire in mente, io vi rimetto la faccia di Uncle Bob, non è mai giusto, mai. Se rilasciamo in produzione, Non è mai giusto rilasciare codice di merda. L'ho detta, scusate. Lo dico in altre parole. Se rilasciamo codice di scarsa qualità, e qui faccio una citazione del mio caro amico Peter, è come se andassimo sulla strada, diciamo, con la macchina a tutta velocità, ad occhi chiusi, al semaforo rosso, e passiamo senza preoccuparci, bendati magari. Fondamentalmente siamo degli assassini potenziali. Okay? Non voglio dire che chi fa l'e-commerce è un potenziale assassino, però quell'e-commerce serve a quell'azienda, a quel venditore per mantenere una famiglia. Okay? Stiamo creando comunque dei danni se rilasciamo in produzione qualcosa che non funziona. Non tutti lavoriamo per il Boeing, no? Però comunque come dire, non è una giustificazione. Non è che bisogna lavorare per il Boeing per fare i test. Quanto vi sentite... In questo momento quanto vi sentite male? Dovete sentirvi male perché sennò non funziona. Va bene. Qual è la cura quindi? È molto banale. Sentiamo? Chiaramente la cura non ha tutti i problemi, però a molti di quei problemi sì, sono i test, no? PyCon rappresenta i test con questa piramide che andiamo ad analizzare. Qui c'è il link, ma se cercate PyCon piramide dei test lo trovate, insomma c'è un articolo molto breve, molto semplice che lo spiega benissimo, è molto meglio di me, ma io ve lo spiego a modo mio. Alla base della piramide ci stanno i test unitari, sono tutti quei test che facciamo su piccoli moduli, su piccole unità. Come? Singole componenti, esatto. Subito dopo ci stanno i test di servizio, che includono tutta una serie di test, e qui ovviamente inizia ad esserci integrazione tra i vari componenti, per poi finire sui test di accettazione, test di interfaccia, che sono i test che di fatto vanno a testare le pagine web nel caso dei siti web, no? Ci stanno anche test manuali fuori dalla piramide, ma chi se ne importa perché tanto noi siamo programmatori e vogliamo automatizzare i test, non facciamo quelli manuali. Ok, perché questa forma? Perché i test unitari, come dicevamo, testano piccoli moduli, piccoli componenti, sono molto facili da scrivere, molto veloci da eseguire e quindi ci saranno tantissimi test che sicuramente garantiscono l'isolamento tra le funzioni, sicuramente garantiscono velocità nell'esecuzione, però ovviamente si perdono tutta una serie di informazioni legate all'integrazione tra le varie componenti. Subito dopo andiamo a scrivere questi test di servizio, test di integrazione, che mettono, diciamo, ovviamente non garantiscono l'isolamento totale, garantiscono maggiore integrazione, diventano più lenti e così via, salendo sulla piramide. Chiaramente i test di interfaccia devono essere quelli strettamente necessari perché sono lenti nell'esecuzione, ma garantiscono ovviamente tutta l'integrazione in tutti i componenti che prendono parte, insomma, a quella funzionalità specifica. Qui vado un po' veloce perché non so quanto tempo ancora, c'ho tempo. Ok. Sì, vado un po' veloce, questo è poco interessante. Comunque i test a database non facciamoli perché tanto c'è chi li fa per noi. Se il database non funziona ce ne accorgiamo prestissimo, non presto. Quindi non vale la pena farlo. Test alle GUI, qui c'è una filosofia, insomma, scuole di pensiero diverse. Le GUI sono molto piccole, non vanno testate, anche perché le GUI, parlando di interfaccia, di colori, cioè, chi se ne frega, quello cambia perché il marketing fa l'A/B test e ti dice poi cambia, non serve testarlo, mentre la funzionalità sì che va testata, no? Quindi cerchiamo di disaccoppiarle, però anche qui scuole di pensiero. Un invece molto interessante è test di contratto. Io li trovo molto interessanti perché pensando e scrivendo un contratto prima di andare a scrivere le varie funzioni nei vari servizi, possiamo garantire che i vari servizi che poi prenderanno, diciamo, giocheranno in questa integrazione, si rifaranno tutti a quel contratto, per cui un provider e un consumer si rifaranno a quel contratto e scriveremo il codice legato ad esso, per cui non potremo scrivere qualcosa che non è conforme, no? Diciamo, vado veloce su questa parte perché Generalmente cosa succede quando iniziamo a dover sviluppare delle funzionalità? Arrivano questi fantastici requisiti, a volte in tomi giganteschi, a volte dividiamo questi tomi in piccoli tomi e li facciamo una sprint, ma sempre dei requisiti all'inizio. Iniziamo a progettare, a fare analisi di questi requisiti, facciamo il nostro buon design, magari qui scriviamo pure il diagramma ER del database, lo pensiamo prima, no? Prima di sapere che l'utente va a utilizzare un dato, e iniziamo l'implementazione, poi andiamo a testare e da quello che ho visto delle mani alzate a mano, e questo è molto male, e poi ce ne andiamo online, tanto ma chi se ne frega, funzionava, l'ho testato sul browser. E poi piangiamo per l'eternità, perché questo succede. Quanti di voi si riconoscono in questo approccio? Dai, onesti, onesti. Ok? Questa cosa, anche se è fatta a sprint, si chiama waterfall, non è agile. Va bene, quello che dovremmo immaginare invece è che il nostro utente, che qui rappresento con la mia faccia quando mi trasformo e quando utilizzo certi siti tipo quello dell'INPS, faccio delle richieste a una pagina web, questa richiesta poi chiaramente viene propagata fino al recupero dei dati e poi insomma mi viene restituita una risposta. Ma io ho fatto una richiesta molto specifica. Perché, se questo è il flusso, partiamo dalla progettazione del database? Boh, vabbè. Tutto ruota intorno all'utente e quindi la cosa che dobbiamo fare è pensare al requisito in funzione dell'utente. L'utente ci chiede, diciamo, di poter fare un'azione in un determinato contesto per ottenere un certo risultato. Okay? Per fare questo noi dobbiamo immaginare il requisito sotto forma di user story, che è più o meno scritto in questo modo. Adesso possiamo essere critici quanto ci pare su questo, però di base c'è un utente che deve fare qualcosa per ottenere un certo risultato. E qui ci immaginiamo tutti quelli che sono gli scenari possibili. Esattamente, mi mancano 5 minuti, vado velocissimo. Tutti gli scenari possibili per soddisfare il requisito, no? Ok, vado velocissimo. Come dicevo, se scriviamo bene il requisito, quello che iniziamo a fare, o che dovremmo iniziare a fare, è scrivere un test sulla funzione. Quindi immaginarci come quella funzione deve rispondere al requisito utente. Per poi iniziare tutta una serie di cicli sulla scrittura di test unitari e quindi andare a testare piccole porzioni di codice che all'inizio falliranno, come fallisce il test funzionale all'inizio, no? All'inizio falliranno, subito dopo iniziamo a scrivere il codice per far passare il test e poi facciamo refactoring. N cicli di questo approccio ci portano al funzionamento, quindi a far diventare verde il test funzionale. E quindi a quel punto possiamo rilasciare online in produzione senza problemi o con meno problemi quantomeno. Qui vorrei fare l'esempio, però secondo me non ho troppo tempo. Diciamo una semplice user story come questa, molto molto basic, molto banale, giusto per farvi capire. Sono un utente del sistema e voglio caricare dei dati in un database, i dati di un cliente nel database. Qui scrivo, quanti di voi conoscono questo formato? Questo è Gherkin, insomma molto utile per scrivere gli scenari, insomma è un linguaggio formale, non ti puoi sbagliare, è anche un buon tipo di documentazione da dare al cliente, perché diventa un contratto di fatto. Se il cliente accetta questo scenario, ha accettato di fatto come si deve comportare, e quando dice ah ma c'è un bug, scusa che bug, dove era scritto? Vabbè, è un altro tema che affronteremo. Diciamo che andiamo a dato l'utente sul modulo di inserimento dei dati clienti. Quando l'utente inserisce questi dati vogliamo avere il risultato che il sistema ci conferma che il cliente è salvato sul database. Velocissimamente scrivo il test, quindi preparo i dati, lancio la funzione, faccio i miei assert per verificare che tutto è corretto, no? Eseguo il test, la prima cosa che succede è che non trova l'app e quindi si spacca. Per cui inizio a scrivere il mio modulo con il mio modello, eccetera, lo rilancio, non trova la funzione inserisce i dati clienti. Allora vado a creare la funzione inserisce dati cliente, lo lancio, passa, bellissimo. Che succede però se faccio questo tipo di test? Dallo scenario che abbiamo visto prima mi aspetto che mi risponda errore. lo eseguo e si spacca perché mi dice che non trova questa chiave. Quindi quello che faccio è andare a mettere la logica molto semplice e banale per verificare che esistono i dati obbligatori. Ok? Lancio il test e mi risponde, insomma, in positivo. Quindi ho fatto passare il test. Ok, l'esempio per i più critici è molto banale, lo so, però era giusto per far capire l'approccio. Quindi quello che abbiamo fatto è scrivere l'aspettativa, diciamo, relativa alla funzionalità, relativa al requisito utente, e poi fare n cicli fin quando l'aspettativa non è stata soddisfatta. Ok, quali sono i vantaggi del TDD? Lo devo dire in un minuto. Intanto facciamo buon design, perché quando stiamo pensando al codice stiamo progettando di fatto, quindi lo facciamo sempre, lo facciamo in pseudocodice, lo facciamo su carta, lo facciamo scrivendo diagrammi, e allora tanto vale scrivere un test, stiamo progettando, no? C'è maggiore qualità del software, perché? Perché scriviamo solo il software necessario alla funzionalità, e quindi non ci perdiamo nella scrittura di tantissimo codice inutile, no? Abbiamo un'ovvia riduzione dei bug, abbiamo visto come funziona, con le iterazioni troviamo i bug e li risolviamo contestualmente. È una migliore documentazione tecnica, perché sfido chiunque a leggere un test e non capire qual è il funzionamento di quella specifica funzionalità. C'è una crescita incrementale proprio perché scriviamo il test, scriviamo il codice e rilasciamo, e continuiamo così all'infinito. E quindi la crescita del software è incrementale, non aspettiamo 6 mesi per fare tutto il codice e poi tutta la fase di test e tutto il bug fixing, insomma, no? Ho finito in un minuto. Maggiore sicurezza nelle modifiche, perché non si regge sugli stecchini. Abbiamo il feedback rapido, il sistema ci risponde subito: guarda che qui non funziona. Riduciamo i costi di manutenzione, perché di fatto stai risolvendo tutti i bug e la manutenzione c'è, però la riduci di molto. E infine aumento della produttività, cioè lo sviluppatore non si concentra più sulla bug fixing, ma si concentra sulla produzione di nuove funzionalità, no? Va bene, fiducia nell'evoluzione del software, perché siamo sicuri che possiamo andare in produzione. Vi consiglio questi 3 libri per chi sta iniziando adesso, ovviamente, 2 di Robert Martin e uno del nostro amico Fabio Mora, dove ho preso molto spunto per fare questo talk. Poi magari vi mando queste slide sul Discord. Conclusioni velocissime: facciamo sempre del nostro meglio, quindi se abbiamo dei dubbi risolviamo questi dubbi il prima possibile. Produciamo codice impeccabile, quindi se il codice non è impeccabile non rilasciamolo mai. E infine cerchiamo di creare impatti positivi con il codice che scriviamo. Grazie.
Sapete che sul sito di PyCon c'è la possibilità, attraverso l'app Slido, di fare delle domande. Quindi io ho abilitato la sessione. Mi sentite, no? Sì, ok. Non so se c'è qualche domanda specifica che è stata già inviata. Abbiamo 5 minuti esatti. Com'è?
Ricordatevi 346. No, ve lo dovete ricordare nel vostro lavoro.
Ok.
Come si chiama il linguaggio formale degli use case?
Gherkin.
Come è scritto?
Ger con la K. Gherkin. G-H-E-R-K-I-N.
Ok, grazie.
Il contratto che voi fate con il cliente, c'è un'interfaccia grafica che lui vede, visualizza e vede la pipeline dei test che vengono effettuati. Avete mai pensato a utilizzare un tool che possa darvi dare la possibilità al cliente di verificare che tutto il contratto sia rispettato? C'è qualche software di questo tipo?
Bella domanda. Purtroppo succede che ci sono i clienti che chiedono ancora quel tipo di contratti e noi cerchiamo di evitarli come la peste, perché il modo giusto di lavorare nel software non è quello di dammi un contratto, dimmi cosa mi fai, non stiamo comprando cioccolatini al supermercato. Ok, tu parli della user story? No, la user story ti racconta il requisito un po' così, quindi tu mi accetti lo scenario, mi accetti, diciamo, i criteri, ci stanno i criteri di accettazione, da lì parte lo sviluppo che è iterativo, quindi tu inizi a fare il mock-up, inizi a fare lo sviluppo basic, poi inizi ad aumentare, insomma.
Però quello è visto dal lato sviluppatore. Lato cliente,
Mhm.
visto che la sintassi all'umano. C'è questo tool, c'è un tool che possa aiutare anche a rendere il cliente più felice di vedere il valore di quanto viene fatto test driven?
Guarda, noi facciamo refinement col cliente, abbiamo il product owner generalmente che col cliente definisce lo scenario, definiscono il gherkin, accettano il gherkin, quindi non utilizziamo un tool del genere che io sappia. Guardo Gabriele che mi aiuta in questo, però diciamo di fatto la buona comunicazione col cliente, basta quella, se tu parli col cliente, ti metti d'accordo, gli fai vedere il gherkin e glielo spieghi.
Partite dalla user story map?
Partiamo da un po' prima in realtà, poi la user story map la facciamo ad un certo punto, però partiamo dagli obiettivi che ha l'utente, cerchiamo di capire quali sono. Poi ad un certo punto arriva anche lo user story map e quindi la definizione delle user story, eccetera, eccetera.
Una domanda,
Vai,
Raffaele, che avevo
sì.
visto.
No, beh, hai mezzo risposto, ma non voglio tenerti un'ora a parlare, quindi te lo dico dopo.
Vabbè, per me insomma ci possiamo fermare qua davanti e sono disponibile.
Sei disponibile?
Sì, sì, ha voglia.
Un applauso.
Grazie.
Vi chiedo di liberare la sala, se è possibile, grazie.
1, 2, 1, 2, 1, 2. He says 1, 2, 1, 2.
Hear it, okay. Okay, cool.
Check, check.
Okay, where it's just here. You have to put it to 1, so maybe just leave it with you or put it in your pocket. So when it's 10 minutes, I'll show you the 10 minutes sign. And then,
So at 12:05.
yeah, this is like...
I will probably be, so it's planned. I know the 45 minutes in total,
Yeah?
and the speech is 35. It will perhaps be a few minutes longer than 35 minutes, but
Okay.
I'm aware of the time.
So do you want me to maybe cut some time from the Q&A session and let you talk longer? And let
Yeah,
people ask
yeah,
you later
probably.
in the corridor. Okay, cool.
And, just wait. And I will tell the people, I hope this is fine for you, that they can get some, that they can get some brochures from me when they leave. Is this fine?
Class here, they told me that.
This one is a dirty glass. What do you mean? Ah, not glasses. No, no.
I don't know where. It's not here. Maybe somebody took it and... Maybe try with the guy from the audio and camera. So the brochures, okay?
I hope this is fine for you. Huh?
Yeah, of course, of course. So it's your company, software?
Can we? Is the audio on? One, two. Try the, like, can you call someone maybe to, like, is there a different mic or anything? Did you, like, turn something on or off? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, this one is gonna work. 1, 2, 3. When we. Try this one. It's like works and not stops working.
What? 1, 2.
Yeah.
It works.
Yeah.
This one.
Yeah.
1, 2, 1, 2. It's not. Just a receiver. Okay. Mic.
One, two, 1, 2.
1, 2, 1, 2, 1, 2. Okay.
Okay, great. I'll just. Hello, everybody. Welcome to PyCon 2024. Sorry for the delay. Without further ado, well, not without further ado, I have to present to you today's speaker. His name is Christian Heitzmann, and he's been long specializing in software documentation and testing, and also teaching in various sorts of fields. So other than coding, also mathematical algorithms and machine learning. He has a company based in Switzerland, Lucerne. Feel free to take some brochures after the talk, and the Q&A session is going to be a little bit shorter because the speaker specifically asked for it, and you can then try and network with him later in the corridor or in the lobby. And questions in Slido. The link for the Slido is in the, okay, this one is not working. Great. So ask your questions in the Slido, enter them, and we'll try to ask at least some of them at the end of the session. So without further ado, Christian, please take it away.
Thank you so much. Thank you so much. If the mic is not working, just give me a wave, and then I will change the microphone, and one of these two will work. Okay. Imagine a typical work environment of a new software developer. During application phase, you get promised the stars. We are the best company, we have the best application, we have the best programmers here in our company. And then you sign the contract, you start working as a new developer, and then it's the first working day, and it's about setting up your new machine. And the best, which you will probably see, is it's not the optimal case, but probably still the best case, that you will be offered a disk image where everything is prepared. So you can kind of copy or clone this disk image, and then your machine is more or less working within one day. The worst case that can happen is that you need to ask your coworkers for help. So your coworkers need to come to your machine and help you for a few hours, for a few days in order to set up your machine. And the typical case is that theoretically there are some wiki pages on this company that describe how the machines are to be set up, but they are either outdated or incomplete. I've never seen such wiki pages that are up to date and complete. Okay, that was the first day. Now we are in the first working month, and this new software developer tries to gain an initial understanding of the architecture. And slowly, this person realizes that there are no API or source code comments. In case if there is any documentation, it is either outdated or it is missing completely. And then he finally has the courage after 1 month to ask his coworkers, and he says, what about documentation? And the nicest answer he will probably get is, we don't do that here. And the worst answer he will get is kind of, so from this day on, the following months and year, this new software developer, or no longer new software developer, will spend his working days doing reverse engineering most of his time. I guess you're all familiar with this situation. So then, what are the typical excuses? Excuse number 1, we are agile. That's why we do not document. Well, I hope you are all proficient enough. Agile does not mean not doing or not having to do any documentation. This is just plain wrong. Then, if the economy is going up, the company has no time to do documentation. If the business is going down, it currently has no money to do documentation. In other words, they never want to do or can do documentation. For me, the math is pretty simple. If you just look at the previous slide and take into account how much time and money it costs doing reverse engineering most of the day. And then another typical excuse is we do clean code or test-driven development or extreme programming, or put your procedure in here. So the source code is the documentation. Nope. It's even too silly to discuss this topic. I've never seen that this is really the case. So if you want to read about many undeniable reasons for documentations, you can take a picture later. You can read these 2 articles I wrote during the last years, and there's a whole list plus some technical stuff. So that was the introduction. First of all, welcome. I'm so happy that so many of you are here. You will find the slides in the late evening under this short link. I always publish my slides after the talk in case I find any spelling mistake or so. And I will also show you this link at the end of the presentation again. So then you can take another picture at the end of the presentation where I will also show you this link again. I assume to the target audience that you are either a professional Python developer or you're working on non-small projects. If you have your little Raspberry Pi hobby project, documentation probably really isn't necessary, but for everything that goes beyond trivial Python projects, I would assume that documentation is important to you. That was about you, now about me. Thank you for the introduction, Slobodan. I'm from Switzerland. I studied computational science and engineering in Zurich. I'm certified in Java, Python, and Spring. Actually, my original language is Java. 3 years ago, I attained a CAS in machine learning, so that's on top of the studies, and I've been developing software on and off for more than 20 years. Then my second track in my career is teaching, so I got 2 teaching diplomas, one in computer science and one in mathematics. I've been doing teaching classes and courses for more than 12 years in Java, Python programming, mathematics, and algorithms. And with my company, Simplexer Code, besides these 2 things, I've been working on technical writing, which means I offer documenting software as a service for companies who don't do this. Parentheses, there are many companies who don't do this. And I write a lot of articles for IT journals, mostly in German, but you could find all of them on my website. Good. Half a year ago, I asked these guys from Swiss DevJobs, that's a job platform on LinkedIn, if they could publish a little survey for me, and they were so nice and they did it. So meanwhile they have 20,000 followers, and this is the most representative thing I currently have. There are 300 votes close nearly, and the question was, what is the state of the software documentation at your workplace? And we see that only 22% claim that they are doing pretty well, and all the others don't even know what this is, or claim that the code is documentation enough, or that their wiki is outdated. So nearly 3/4 of the people or the company have the problems that the documentation is not in the state that it should be. You need to be aware that every day you do not document, you increase the software debts every single day. And if the debt does not show up with you personally as a developer, it will probably show up for your employees who need to read, or you need to work with your code, perhaps today, perhaps a few years later, but someone else will suffer if you do not suffer on your own. This goes on until one day you reach a point where reverse engineering takes up most of the time, and then you probably know this situation. And just be aware, documentation debts are also technical debts. I don't know if you're aware of the word technical debts. It's very, we use it a lot in German, technische Schulden. I don't know if you are aware of this term in English, or here, even in Italy. Okay. Now, documentation is not documentation. You need to ask yourself actually 2 questions. The first question is, who do you want to address, which is called the audience. There need to be different documentations for external developers. So if you publish a library and someone else works with your library or with your API, these are external developers or end users. Product managers, product owners are another audience. Internal developers, again, are another audience. So each of these people need different documentation. There are different kinds of documentation. And the second coordinate is, what level of detail do you want to document? You can start with, or if you want to document the overall software architecture, that's usually done in external documents and using a lot of diagrams. If you want to document classes, interfaces, APIs, you do this using doc strings, for example, in Python, or Java doc in Java. And if you want to document function internals, you usually do this with source code comments. Then you only read them when you read the source code. Now I give you 3 things which are very important if you want to be successful in documentation. First, so please forget Word or Confluence. Don't think, I don't know if you've made the experience that kind of documentation is written in Word files. This just doesn't work. It's just not good. I don't want to use strong words here. It's just not good. Don't document using Word or LibreOffice, or don't document directly in Confluence. It's just, it's a one-way street. You should use a lightweight markup language. You probably know what a markup language is. It's a machine and human readable language for structuring and formatting text and other data. That's what Wikipedia says. You all know HTML plus CSS. You probably know LaTeX. These are markup languages. But the problem is they're kind of clumsy to write them by hand all the time. That's what lightweight markup languages were invented for. They have a simpler syntax without disturbing the writing and reading flow. You probably know Markdown. Have heard of it? We are talking about restructured text today. AsciiDoc, well, not talking about a little bit about AsciiDoc, and there are various wiki markups. So if anyone edits pages on Wikipedia or on their internal wiki, you use a wiki markup language. These are lightweight markup languages. And here, some years ago, I made this little unscientific diagram on my own, and I claim the more flexible a lightweight or the more flexible a markup language is, the more complex it is also. So LaTeX, you can do everything, including the tip of the eye you can control, but it's kind of, yes, I've spent too many years with LaTeX. I'm an expert in it, but I can understand everyone who doesn't want to use LaTeX anymore. And on the other side, you have the Markdown, which is very inflexible. It has a very limited functionality. But on the other hand, it's very easy to use. So kind of the middle, I would claim, is AsciiDoc or restructured text. OK. Now, the second thing, docs as code. Who has heard of docs as code? Just a term. Not too many. OK, docs as code simply means that documentation is treated the same way as source code, which means you can write your documentation using the same IDE you use for your programming. It means you check in the documentation using the same version control system that you use for source code. It's just parallel to source code. It's actually the same repository. It's just a folder in there. You use the same process integration. For example, if you have pull requests or code reviews and so on, this also means that documentation also goes into this process. And you use the same CI/CD pipeline, which means documentation is also processed with your GitLab or Jenkins and so on, and then the files are exported and so on. So it's also the same pipeline. It's important that documentation needs to be in text format. It only works if it's in text format because you want to make diffs and so on and to check in. It does not work with binary format, so that's the reason why you cannot check in and should not check in Word files. It simply doesn't make sense. You want raw text. But with markup languages, what I showed you the slide before, it perfectly works like it works with source code, because markup languages actually are source code. OK. So, and the third thing is, probably you know the problem. Let me switch the side now. Good for the camera? So, here, there's another half of the audience. Perhaps you know the problem that you have some documents and you find out that the documentation actually is outdated. And one reason for this is that the documentation is too far away from the source code. So when you take care that the documentation is close to the source code, this probably won't happen, because if you change something in the source code, you will see, oh, there's some documentation. So when you know JavaDoc, for example, you have a method, and on top of the method, you have your JavaDoc API, and it's very hard to not see that there is some documentation regarding this method. So here we have the JavaDoc. In Python, it's docstrings. I will tell you in a second. C#.NET, you have another thing. JavaScript, you have another thing. So the big advantage is the close proximity between source code and documentation. That's very important and fundamental. Good. This was the general part. Is the microphone doing fine, actually? Perfect, because I sometimes think that it's getting louder and so on. OK. Now we are coming to Python directly. Python uses docstrings for documentation? First of all, who knows Java doc? Who knows Java and Java doc? Okay, a few. Python uses docstrings. Docstrings appear at the beginning of a class or function body. You will just see a screenshot in a second. And it's similar to Java docs, but Java doc you write on top of a method or on top of a class, and in Python you do it below the class or the method. It looks like this. In Python we have a class, then the first thing you do is you write the docstring. You have a function. The first thing you do, you write the docstring. Docstrings start with 3 double quotes. And docstrings can be accessed at runtime, so actually they are not comments like in Javadoc, they are actually strings, and these strings can be read out during runtime. So for example, this main function here, if I simply call my function dot underscore underscore doc underscore underscore, it will show me this one here. So this is part of the function. I can read it during runtime. And docstrings could and should contain restructured text syntax. What this is, you will see in a second. There are several tutorials for restructured text, and to make it short for you, the best one for Python purposes is this one here. And I will just show you how it looks. I will just show you how it looks like. This is the restructured text lightweight markup language. I will just scroll through it. Here you can make the things italic, bold, code notation, and so on. Lists, numbered list, unordered list, etc., including source code, writing hyperlinks, writing section titles, and so on. You can all find on the website I just showed you. So this is the best starting tutorial I can suggest to you. Now, when it's about generating Python documentation, perhaps actually every Python book mentions this. There's kind of a help command. Have you ever heard or used the help command? You can type help and the function name, but I don't know if anyone uses this. So this is just command line, and I would not read documentation using the help command. Then when you read Python books, they sometimes mention the pydoc command, but I also do not suggest using the pydoc command. It produces very old-fashioned HTML pages, so also no. And the standard way of creating Python documentation is using the Sphinx documentation generator. Now, Sphinx per se interprets restructured text documents, so you can use Sphinx as a standalone solution. You can write your documents of any kind, like your baking recipes or your to-do lists or the essay or the report for your company. Everything which is Python independent, you can do in using Sphinx. If you want to connect it to Python, which means if you want to use it for documenting the API, you need an extension which is called Sphinx API doc. And then if you write your doc strings in one of these 3 conventions, it is able to interpret it and display a nice API documentation. So by default, you could use the PEP 287 restructured text docstring format, but it's written in gray, so don't use this because this is quite an old-fashioned way of writing what parameters are, what arguments are, what exceptions will be thrown, etc. Don't use this. There are 2 more advanced formats. One of them is the NumPy docstring format, and my personal suggestion, the Google docstrings format, which you will see here and which I will show you now. You need another extension, but it's just a detail. Just to tell you, it's called Napoleon then it will be able to interpret NumPy and Google. And so now that you can imagine what the Google docstring format is about, I will just show you here. So that's the section 3.8. And they tell you, is it large enough? They tell you how docstrings should look like. So far, it's nothing special. But now when it comes to functions, here you see an example with the section args. You describe the arguments, and returns, you described what is returned. All of this is restructured text syntax. And with races, you describe what kind of error will be thrown in this function or method. Actually, that's all there is about. And you are pretty free to style the messages the way you like. So if you are familiar with Javadoc, it kind of all looks the same. It's kind of black and white Javadoc, it's kind of boring, but when you look at the Sphinx documentation from Python modules, they are much more colorful and more, how do you say, not so monotonic. They look much nicer. Okay, I just showed you this one here. And now I want to demonstrate how this works. Yes, we are good on time. So when you have the slides, you have all the steps I'm showing you here. I do not demonstrate all the steps, but when you have the slides, you have everything written down. I will just show you after I did the pip install. So with the pip install, I installed the Sphinx packages, and here I have a little program which is about a bank account. It has two exceptions and just a bank account with deposit and withdraw and so on, and just to demonstrate the use of how documenting works. Now, it's pretty simple. I create a new directory, make dir docs, and I go in there. And the best thing to start is when you start the program called Sphinx Quick Start, which is installed when you did all the pip install stuff. And then it asks you separate source and build directories. Then we choose yes. Then let's make a project name. PyCon Italia. Author name, let's type in my name here, which is difficult with one hand. So. And project release, this is usually my style of writing versions, 2024.05. Language English is fine. So now we see we got a docs directory with build and source. Source means that's everything the documentation generator needs to know. And I hope that this works. Demo. No. Oh no, I forgot one. So now if I want to create the documentation, I simply type in make HTML, and then it creates all this HTML stuff in the build directory, and then I open it in the browser, and this is what the starting page looks like. Now usually you do all the setup in the conf and in the index.rst files. I have prepared this already. I have prepared this already to save some time. So I did some configuration here, and I added the Napoleon and the Autodoc extension, and I changed the theme so that it looks a little bit nicer than the default theme, and so on. And now I simply need to call the Sphinx Autodoc, which I told you about. It should be there. Why isn't it there? things API doc, not Autodoc, API doc -o source, and then the path to the module, which is Sphinx API doc. That's the path to the module where the bank account module is in there. So hope that this works now. Now it has created some restructured text which describe the module, and now I simply do the make HTML again. Build succeeded. Whew. Good. Refresh. Now we have a different theme. And I added some text here, some demo text with lists and how you can include mathematical formulas, how you can include source code, even how you can create diagrams by textual representation. This is pretty cool. Just have a look at the source code. Actually, the diagram is actually here. So this is the source code, block diag to get this one, and this one here is the source code to generate this UML diagram. So this is pretty cool. This is called diagrams as code. And this one is the module I talked about, and here we have the class bank account, and now you see that it's perfectly and neatly described. Okay, when you have the slides, I have to hurry up a little bit. Here I collected the links for you. You have a gallery of all the different themes you can use. You have a list of projects that use things, so you can get an overview what kind of large projects can be documented using things. So this is really a cool thing. Some specific examples of classes. Here I just show you one thing, which is the NumPy ND array, because it looks quite cool. So this is a things documentation of the class NumPy ND array. Probably you know it. It can include formulas. It has some nice admonitions, some nice boxes, and so on, a nice overview. And I also gave you the link to the source code. So this one is the restructured text. Now here you need to code. This one is the restructured text syntax in order to achieve the page which I just showed you 1 second ago. So you see, even if you do not compile it or generate it, you can still read it and think, yes, I can understand and edit without even generating it. Okay. Now, my personal favorite is AsciiDoc, but this is a Python conference, so AsciiDoc, I need to speed up a little bit. When you read the article, which I will show you at the end, I explain how about 2 years ago, I compared all the lightweight markup languages and tried to find the best one. And I kicked out everything which has an application focus, like WhatsApp and Slack and so on. And I kicked out everything which is outdated or not longer maintained. And then it resulted in this top 4 here: Textile, MediaWiki, Restructured Text, and AsciiDoc. And perhaps you're missing one language. Markdown. So Markdown gets a special slide. It's by far the most popular lightweight markup language, but it has no standard. It's not standardized. Thus, it has many flavors or dialects. You need to install plugins or HTML code in order to achieve even some basic things. And it doesn't support tables, cross-references, footnotes, including YouTube videos, and so on. So my suggestion to you, just don't use Markdown. Everything you can do with Markdown, you can also do with AsciiDoc, with restructured text, plus many things more. Now, since AsciiDoc is such a cool language, I asked myself, is it possible to use AsciiDoc for Python doc strings? And the problem is I'm not aware that there is any good Sphinx plugin or converter or whatever that could interpret doc strings in ASCII doc syntax. I don't know if it even makes sense because I strongly claim that one should stick to standards, and the standard for documenting Python code is restructured text. So I don't even know if it's a good idea to use another language. So stick to Python standards, and Python says use restructured text, like using Java doc for Java or JS doc for JavaScript, etc. Yeah, I'm aware. So, and another thing is keep your doc string simple, so don't try the most advanced features and syntax within your documentation because it gets difficult to read and so on, and it makes you more language dependent. So what in general, keep things simple, which includes doc string. Don't try to be too fancy with the way of documenting the things. Now, if we ask ourselves the other way around, okay, ASCII doc for Python, probably not. What if you use restructured text for everything, for all kind of software documentation? And I think this would be technologically fine. You can use restructured text for everything. Coming back to ASCII doc is a nicer language. It's easier to learn. It's more generic even for non-techies. But in the Python context, it's non-Pythonic, which I explained in the slide before. Now, restructured text would cover Python doc strings, but would not be compatible with Java doc or JS doc. On the other hand, it has a steeper learning curve. So restructured text is kind of nerdy and clumsy, and it's more aimed at tech-savvy people. So then I was thinking about compromise. What if you have tagged source code includes in ASCII doc, which means you have an external or several external ASCII doc documents. And what they do, you have tags in your source code, and your ASCII doc document has a look at the source code and includes the part of the code and then displays them in this external document. This would be a nice solution. It would work similar across all programming languages. So when your software product or your company uses a lot of different programming languages, this might be perfectly fine. This might be a very good idea. You get a language-independent way of documenting things, but on the other hand, you then introduce a distance between the source code and the actual documentation. And that's what I said at the beginning could be a disadvantage, because then you could miss, when you change something on source code, you could miss the fact that there is some documentation relating to it. That's the disadvantage. There's no general solution. I simply suggest these are fundamental decisions, so simply carefully discuss it with your colleagues. It's not an easy decision. It's not decided within 5 minutes. But I presented you the options. Okay, I'm coming to an end. We're doing fine, perfectly. Okay, 3 ingredients for successful software documentation. First of all, let me remind you of what I said at the beginning. You need a docs as code infrastructure. This could be, in Python, restructured text in combination with things. This could be ASCII doc in combination with Antora. That's the generator for, that's the things way for ASCII doc. You could use Java doc, HTML, and so on. It doesn't matter too much, actually. Just don't use Markdown. Now, the second thing, you need few but responsible people for the software documentation. This might probably surprise you because you think, well, it's good if everyone documents, everybody has to document, everybody can document. But there's a saying which says, too many cooks spoil the broth. I've never seen that it works. So there are too many different different qualities. there should only be few people who are very good at documenting and who want to document who do this job. You could call these people, these few people, technical writers. You could call them doctator. And if you ever wondered how such a doctator looks like this. And number 3, you need a documentation guide. For example, have a look at the GitLab, how they have a documentation style guide. It defines what language you use, if it's British English or American English, which, by the way, is an important decision. If you capitalize the section titles, etc., etc. So there are some things, the more you get into it, there are some things that need to be regulated. Last slide. Documenting can be learned. Really, it can be learned like programming. Just be open-minded and read and hear about it. It all depends on a systematic approach. I'm always surprised that you have everything defined regarding software documentation, and you have the tests and the pipelines and the procedures. But when it comes to software documentation, so everything is defined for software development, but not for software documentation. When you ask people what system do you have for documentation, they simply say, we write a little bit. That's not systematic. And get external help if you want to avoid re-eventing the wheels. There have been many things going on during the last 5 to 10 years. Don't reinvent the wheel. There are many cool things regarding software documentation. It's no longer writing stupid Word documents. And specific next steps, read this article where I talk about the lightweight markup languages. It's in English and in German, so the blog post is in English, and then you have a link to the German PDF, but I guess no one speaks German here. Then take my software training program and my business card. So when you leave the room, please feel free to get my brochure and my business card, and feel free to follow me on LinkedIn in order to stay up to date about this topic and many more topics. And here is the link again. Thank you so much for your attention. It was a pleasure.
Okay, thanks, Christian. It was a great presentation. Do you have time for some questions? Okay, great. So the first one is actually the last one asked, but it's kind of interesting. Do you use LLMs for technical documentation generation professionally, and what's your way of working?
So I don't use LLMs. I just have one saying regarding documentation using LLMs. Machine learning documentation is documentation of the obvious. We can put in a function and it tells us what to do. This is not interesting. So we as humans, and this is valuable information, we should write down things that are not so obvious. Why have we chosen this? Just think of the word why. That's the most important question. Why? Why have I chosen this approach? Why is it written like this? And this is something machine learning cannot explain.
Okay, thank you. And another one, we might have time for another one. Have you got some suggestions regarding documentation of SQL queries, which are often needed for data science projects?
Well, SQL code is also code, so write it down the way it is. SQL, it's like regular expressions. It's nice for those people who wrote it. I wrote it, I understand it. It just took me 2 hours, but now I understand it. But the people who read it no longer understand it, especially, regex, regular expressions, which, and, SQL, which just explain and write down what you did and think of others. Others need to read it again. You invested 2 hours for the SQL statement, and others need 4 hours to understand it. So please write down. You also have comments in SQL, so simply write down what you did.
Okay, thank you, Christian. One more round of applause for Christian. Thank you. Hello, everybody. Welcome to PyCon 2024, if you weren't in this room before. So today's presentation will be given to us by Guillaume Lemaitre, and it's going to be about the augmented retrieval of the documentation of Scikit-learn documentation. So currently, the Scikit has the exact search of the documentation, and we are going to explore how this can be augmented. So please, also please be sure to use the Slido, which link you can find at the actual presentation link, so in the schedule of the conference site, and use it to ask questions. And please give a big round of applause to Guillaume.
So, hello everyone. I'm Guillaume, and I will speak about two things, so RAG and about Scikit-learn. So just about me to know who I am. So that's very irrelevant now. I have a PhD in medical imaging, but I mean that's useless. And afterwards, now I'm open source software engineers at Probable, depending where you are from. And I'm a core dev of Scikit-learn and a core dev of imbalance-learn, which is another libraries as well that check some other aspect of Scikit-learn. And that's my GitHub. So, motivation for that talk, and is a kind of a different RAG talk, I hope so, which will take basically the RAG under another angle. So basically you have like many talks here. If you want to know how to make a RAG, you can go and they will explain you. Here, what we wanted the real motivation is that we have this Scikit-learn website, which by the way, it doesn't look like that anymore because we released like a new version yesterday and it's much better. But the search engine, which is on the top there, is kind of very limited still, even with the new versions. So basically, when you want, what we wanted to know is like, can we do better than what we have? And I will just like motivate what are like the limitation of this search bar. So the limitation that you have is if you just make a search and that you make a mistake, then it doesn't find anything because we make exact match. Okay, so we all do mistake when we type, so this is a bit annoying. So if we would have like kind of fuzzy search, that would be much nicer. And if you go in the natural language way that you would expect that if you type a sentence, then you will find like the matching like page or whatsoever, that doesn't work very well as well. So we match some words, but basically that doesn't understand like the meaning of the sentence. So in this way, we wanted to have a kind of, maybe everybody is speaking about LLM, so Scikit-learn doesn't do any LLM, but maybe we can like look at them and see what they do. So the idea was to improve the Scikit-learn user experience. If they use like this search bar, maybe we can propose like a new thing that will be super cool. The second thing is that I wanted to learn a bit about LLM because everybody was speaking about that. And last thing is like I really wanted to come here. So yeah, that was nice. So let's see. So first slide just to give some concept about RAG in case that you didn't attend any talk yet about it. So here, when before to speak about RAG, I will speak about how we deal, what is the framework that we deal with basically here. And it's more about zero-shot prompting. So you have ChatGPT, you ask a question, is answering to you. Okay, that's what we are here. And the way that we have that is that we have a model, and then the model can be either on Mistral, because you are French, Meta or OpenAI, and then you can either like go programmatically because you have like the model on your laptops or locally or on the servers, or through an API if you have OpenAI. Okay, so you can ask the question there. And then you have the front end, basically that just make like the discussions and the message going through. So what is a RAG here? The RAG is just before to answer the questions, you will just go through a database where you want to find context of document where you are interested in, and like find those documents and provide them to answer the question. So you will not anymore ask the LLM just the question, but you will say answer the questions with this context that should help you to basically to answer these questions. Okay. So in our case, it's typically a user will ask a question about Scikit-learn, so we know that they should come into the Scikit-learn documentation somehow, and they want to find where the things are. So probably if we can find what they want from the documentations and provide that into the prompting, then we can better answer the questions. So if we look at more precisely like the information retrieval, so now instead to have one program, we have two. Okay, because before we had the LLM program, now we have information retrieval programs. So we can look at like the second part that was the information retrievals, and let's say the big picture is the following: is we have the questions in some way we have to vectorize that things. Okay, so go into like numerical space, and then we have a database where we already vectorize content from the documentations, and then we want to retrieve through that database the closest, basically, vectors, and then go back to the original context. Okay, and this context that afterwards will pass to the prompting. So here we'll see several methods that you can use, and we use basically two approaches, but that's the general idea of the information retrieval. And this is not new. Okay, this is like research from, I mean, Google was doing this, okay? So this is like already 60 years that people look at these things. Okay, so what about the RAG? That should be a fairly easy thing to do, okay? So we do all talks because it's that easy, that's why we speak about it. And if you look at the internet, this is very easy. You can do a RAG in 50 lines if you listen Scaleway, but you can do it in 4 lines of code if you do Clarify. You can put it in production depending of like if you use Llama Index or any scale. And if you are Mistral, basically, you can do in like with all the different library that you can find. So it seems that this is something very easy. And the difference between, I say, my talk and those talks is that I'm not selling you any models. Okay, I'm not Mistral. I'm not selling you any computes. Okay, so I will be critical on what it costs. And I'm not as well writing in a library. I don't really care. Okay, so here the idea is how useful, how possible this is to put it in production for in a perspective of an open source project. But I put as well some rules of what I wanted to do. Okay, so first this is a POC. I'm far to be an expert in LLM. Okay, that's not my things. What I didn't want it to do is to pay money. Okay, so I'm cheap. So I wanted to develop something on my computers, like make a POC that can run. I didn't want it to bother with API of OpenAI or stuff like that. Okay, I wanted to have like my model on my laptops. I wanted only to write Python codes. I'm Scikit-learn person, so I wanted to have my Scikit-learn API in some way. And just to understand basically the tool that I was manipulating, I didn't want it to use a wrapper of wrapper of wrapper of wrapper. I wanted to use like let's say, bare bone things and just put my own wrapper on the top, okay? So, and the idea was just to like have this set of rules and see what we can do with that and what are the tools which are available and where we can get started and having something working very well. And of course, I needed to find a cute name, so I call this Ragaduck. So all the experiment that I will speak or whatsoever is available on that repo, with this QR code. So if really you want to run it locally, you can always do that. Okay, so you can like take the repo, like train the retrievers, and then you will have a version of Scikit-learn that is there, and then you can even ask you questions. Okay, hoping that basically it doesn't burn your computer. So that's and. The only thing that you need to know is that it's not smarter than a rubber duck. Okay, that's. So what did I use there as stack? I used so several stacks that are up there. So I will go a little bit more into details in the information retrieval. But basically, the library are just pick up from a bit everywhere. So I use Llama CPP with Mistral because. I'm French, so I say, okay, let's use the French people in Paris. And I use Llama CPP, but of course there is over interface. You could use not LLVM, VLLM, sorry, and do whatever. I mean, it's not the one that are like I didn't make the choice because they are performant. Okay, I just make the choice because they were easy to use, easy to compile, whatsoever. So I use Llama CPP Python for that, and then in the information retrieval, I use sentence BERT and face. That's the same. You have stuff that are much better than face nowadays. And otherwise, I just reprogram as well some of the estimator like BM25 because there is no implementation out there. So I just like re-implemented that one. And for I'm not a front-end guy, so somebody did that, and I just like took it. It's in REST API, and it worked very well, and I just like modify it and make it as simply as possible. Okay, so let's dive into like the RAG part. Okay, so how do you build basically the database, and what are the important things there? So if you read like the document that do a RAG in 15 lines of code, they will say, take your documents and you create chunk, okay? A chunk is just like a piece of text with an overlap and everything will work, okay? So great. However, so we can do better than that, and I will show that if you don't do these exact things, yeah, you have something working, but it doesn't work. And in Scikit-learn, we have as well 3 types of documentation that we can leverage. So I will look at the first one and try to think what are the problem that you can have, like with the chunk strategy that we have before. And then we can think about like the different type and what we can do to improve that. So the first type of documentation is the API documentation. So it's looking like this page where you have the class name, the parameters, a description of each of the parameters. And if you're an engineer, the first thing that you should think of is what type of question should I answer as a user? I mean, what if they visit that page, what questions they can come with? And usually will be what are the parameters of the models? What are the value of that parameters? Or like things linked to that, okay? And the very interesting thing is if I use just like a normal retriever, and by checking like with the chunk that we have before. And I want to answer to that specific question, which is like what are the value of the strategy parameters in the dummy classifier. I will get match of words that are along basically the strategy, okay? And then you will find me like chunk. And for instance, I will find a chunk about strategy for the dummy classifier, which is actually the one that we want. But then I will find as well for the dummy regressor, okay, because it's also like they are the same parameters, so without knowing the context, that will come up. And the same with a simple imputers, because we have as well like the same name, okay? And the problem is that those chunk here is what you are providing to you to answer the question to your RAG. So your RAG will come, and without, let's say, more information, you just give those chunk. Then it's completely failing by telling you that, okay, the strategy parameter doesn't exist, which is like, I'm sure that exists, but okay. And then it's just telling you like, he's just mixing like things together. So by telling you like wrong things and even making like some grammatical errors in the middle, which I have no idea why, but. So how can we just like this? So here there's a problem of ambiguity because we have the same parameter that come in different piece of information, and somehow we need to provide chunks that could help basically the models to disambiguate the informations. And here the easy things that we can do is because we are using NumPy doc as a standard. So here these are documentations, and the way that the API documentation is written is following the NumPy doc standards. And it comes with a wrapper. So we can easily get a structure, the information structure by NumPy doc. And from that, we can recreate chunks where we can inject, for instance, that, oh, the chunk that you will have is coming from that specific class. So that's already solving the problem for the LLM, okay? And then in this way, you can find some strategy where you just like create different chunks with the informations. And if you provide those chunks to answer the original question, in that case, the models start to be able to disambiguate, okay? And the first reason as well that I should have mentioned is that Mistral 7b probably have never been trained on the API documentation of Scikit-learn, so that's why it was not able to answer the question at the first place. If you use already like a huge model, probably it was trained on that, and then you don't even need the RAG because you already saw the information. So here it was, this is one of the things. Okay, so other type of documentations that we have is the user guide. The user guide, in that case, we could have, I did, because I did exactly the naive chunking. I could have done a bit more by actually finding the sections and being sure that when we chunk in a good way, okay? But here I didn't take care. And I don't use the images as well. And then we have another thing, which is the example gallery. In this case, we use Sphinx Gallery, and then Sphinx Gallery also allow to like find different part of the documentation and the section. And in that case, I use that to create the chunks. Okay, so it means that I will have a sections, which is really the context inside that sections is meaningful with the code associated to it. Okay, so I really use that. And I have two types of documentation, one that is usage example, one that is tutorial. So the usage is very like, you have a single section. So here we just make blocks, and the other one just like find the sections. So regarding the retriever, so how do you, one that you want to, you have your chunks, you want to create your database. And here you have two solutions. You can either go with lexical search. So this is the BM25. So the idea is to look at the word, how many times they appear, and then you create a sparse representation of that. And when you have a new document, you just like count the word, and then you check if there is one vector that match depending on the score, okay? So this is like very cheap. This is easy to get like the invert indexing case, but there is no semantic, okay? So it doesn't understand the semantic. It's just looking at word occurrences in that case. And then you have the semantic search, which is like through the BERT models with pre-trained embedding. And in that case, it's much more complex to compute the distances because the space is dense, okay? It's not sparse anymore. So it's much better in terms of finding meaning in the sentence, or in the document, but you need to have approximate nearest neighbors probably to find the vectors, okay? So that's why we need face in that case. So you have those two things, and we just try to make those two search and combine the results. So it's a piece of code just to show to people how that works. So in some way, here I have a Scikit-learn pipeline where I'm using the convectors, and then I have a retriever where I need to pass basically the convectorizer. And before that, I have the API scraper. Okay, so it's a pipeline with like different steps. I just need to feed the documentations, and at the end of my job here, I just need to dump, basically to picker the retriever. And I can do exactly the same for the sentence retriever, and with the same extraction stage, like fitting the models and then like dumping the models. And I have a final stage where I will have different chunks coming from the different retriever, and I need to re-rank depending on the positions, and you have like cross-encoder that can help you here. Okay. Prompting, nothing new. Okay, you are an expert. You need to answer to my things. Just use this context. And if you put everything together at inference time, it looks like something like this. Okay, so you load all the models. You have the cross-encoders just to get like the different to reorder basically the queries. And then you pass this to the llama index, and you ask to answer, using those retriever and this LLM, just answer to the query. And this is basically what's run there. So just as demo time, just to show that it works. So I have an instance somewhere. Thank you. So I'm using Pixie. You should use Pixie. You should like look at what it looks like. And so start Rager duck. CUDA. Okay. And so the idea here is that you load the models, hoping that you have internet. Yeah. So is what ragged look like, and then you can ask you questions. What are the parameters of logistic regressions? Even with typos. Make me quack. Okay. And then, so this is pretty fast because this is running on the GPUs on the machine on Scaleway. But if you look at the log, basically, what happened behind the scene is that's my prompt. And just before are the retriever. So basically, we pass like the question to the retriever. We just get back all the different chunks. And here, this is my prompt. So this is the start of the prompt. And then we just pass the source and the query. And then the model is just answering like, OK, what are the different parameters? And then like putting you the source that basically you find. OK? And in that case, you just run that. So this, you can run it locally as well on your laptop. This is exactly the same. So 2 slides. First, evaluations. There is none. Okay, so it's where this is starting to be complex. So we are an open source project. If we want to really evaluate this, so what people do usually is that they will ask ChatGPT the same question. They say, yeah, we agree with another LLM, which is for me very disturbing. Okay, so if I want really to know how I solve a problem of a user, I need to collect data from users, and I need to check on those. Okay, otherwise I don't know what I'm looking at. So for the Scikit-learn project, we decided that we'll never acquire any data from users, even if we are GDPR. We could be GDPR compliant on there, but we don't want to bother with that, because in case that we leak any data, we don't want to bother with this as well. Okay, so we don't want to do that. But it makes that it's impossible to evaluate the RAG, and it's impossible to fine-tune any component. So maybe for a use case here, we could say we can publish this app somewhere, and if you want to opt in, then we'll collect your data, and then we will make this open to everyone, and then you can use a better LLM. But it's not the case for Scikit-learn here. And the second thing that I didn't speak here about, but I think I have inside the final thoughts, is the cost. We are poor open source projects, so if we need to use some like scale GPU to retrain or fine-tune, we don't have the money for that. And if we need to serve the model itself at the inference time, we need 1 GPU. If we have we have more than 1 million users a month that look at the documentation. If everyone start to do queries, you start to make the numbers, we might need a 10,000 euros check just for people playing with something online. Okay, so it's fine with OpenAI if you have subscriptions, but on our side, that might be complicated as an open source project to actually. I mean, this is not affordable. Okay, a part of if people give us like free resources for that. So this is where you have like issue with that, and then we can as well question what we try to solve as a premise. So I started with my search bar, and I was not happy with what it is. But maybe the middle ground is not to be able to answer questions, but to offer much better, like so for example, the information retrieval system, which is cheap. So maybe this we can offer it. So we can offer something that is fuzzy matching in some way, and that would be very cheap to have, and we can probably have that. And one of the solutions is Algolia can provide such type of stuff, and I think that we'll explore it in the futures, and that should basically answer the questions there. But we have to evaluate as well how good this is. And I think that's it. Yes. Thank you.
Thanks, Guillaume. This was an awesome presentation. So we have one question in the Slido section. So do you see RAG-based search as an alternative or as a replacement to traditional search engines?
I have no idea. I assume that it will depend on how people. So so now I'm old. I'm 35 or 36. Let's say we are being used to search with, like, how we search in Google. So basically by terms-based search, and we're very used to that. Maybe the new generation that is coming is used to ChatGPT and they just switch to a natural language. And if we don't adapt our tools to that, then they will not know how to use our tools. So I wouldn't say there's one or another. So probably, yeah, if people start to get used to the other things, then we might need to look at like natural language questioning.
Okay, there are two more. Could you share some details on the re-ranking? What did you do? And did you observe big improvements?
So did I observe big improvement? I have no way to evaluate. So that's easy. I don't know. I hope so. So regarding the method itself, this is a cross-encoder from sentence BERT. And the way that it works is they train basically a classifier that gives a score to the things that you observe. And that was trained on the Bing request. So this is not fine-tuned basically on our use case. So it's something that we could fine-tune and that we should evaluate. But to do that, we need to have user data for being able to do that. So the only way to be able to do this, yeah, we need to collect data and then we can evaluate. But otherwise, yeah, that's the way that it's a pre-trained models that is a classifier that score basically based on data that come from Bing. So we are as good as Bing.
Okay, we have two more. I think we have time for both. So the next question is, why not use the Scikit-learn GitHub repo instead of scrapers?
Because it's so some of the things we generate on the fly, so we have some more info. But at the end, like NumPy doc, we use the GitHub repo. We use like the original code, so we don't even like go inside the documentations. The examples, we use as well the Python file. We don't use the HTML one. The user guide is a more complex one because we generate things, and then instead of parsing the HTML, I will need to parse the RST, and basically I don't have tools. So this is the same, like is as developing is the same. So here we are using part of the GitHub repo at the end.
And we have one more at the end. Did you attempt any other forms of retrieval, such as Colbert v2?
So I assume with Colbert v2 is just that this is just a pre-trained model. So here, the different models. So instead of the sentence BERT, we could swap any type of models which is compatible. But again, we should have data to evaluate it to know if we just improve something or not. Because, I mean, one of the things that we know is that those models are supposedly good at solving the task that they have been trained on. And here, we don't know if this is the case. So until that we don't have data, I cannot answer basically like correctly.
Okay, thanks, Guillaume. Awesome presentation. One more round of applause for Guillaume.
Hello, test, test, test. Hello, test, 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 test.
Check, check.
Sure.
Hello, everyone. So our next speaker is Riccardo Magliocchetti, and his topic is Django async yet?
Thank you. So, hi everyone. My name is Riccardo Magliocchetti, and today I would like to try to answer the following question. Is the Django ecosystem, or better, its API ecosystem based on Django REST framework async yet? Let's find out. So actually, I think I got the talk of the title of the talk wrong. So it's back? No. So sorry, it was a bit clickbaiting. But to my defense, I thought about this talk at the end of last year. So at the time, I was working as a backend developer for a couple of companies. The stack of these companies were like common one, like Django monolith, Django REST framework for APIs, and PostgreSQL as a database. Both code bases were mostly IO bound, because all the CPU-intensive tasks were just already delegated to queues, so already run in a synchronous way. And concurrency in both places, both companies, was based on processes. And so that means that with higher traffic, you had to spawn more processes, and spawning more processes means consuming more memory. And by consuming more memory, okay, check, this work. Okay, so mic change. Like in both companies, we were using processes for concurrencies. So I was saying that with more traffic, you have to spawn more processes. More processes means using more memory. And using more memory means paying more money to the cloud provider you're using. So imagine your CTO or CFO or architect or team lead or whatever, approaching your desk and saying, what can we do to improve the usage of these machines, what we pay, but we consume only 20% of CPU, but the memory is almost full. And so my interest in thinking about transforming these synchronous services into a synchronous one. So I was not interested in making things faster or having lower latency. Just better use of the resources I was paying for. And possibly without rewriting my code or the API code from scratch. So, Django developers have been working on asynchronous support since years. And also the PsychoPG3, the asynchronous driver for PostgreSQL, has been released since, again, years. The possibility to have a full asynchronous Django backend is coming together. At the moment of writing, there are still some missing pieces in Django to have a service running completely asynchronously. And some synchronous code is reused also in the synchronous path. And this is possible thanks to some helpers present in the ASCII-ref package that bridge the two words. So you can go from async to sync and the other way around. Now, Django REST Framework choose another destiny. If you go to the discussion forum, you will see a discussion by its developers about discussing asynchronous views. And the decision was more or less like, OK, I see there is a package called Async Django REST Framework available. We don't want to invest in the asynchronous world. And so we delegate asynchronous support to external packages. So a quick poll, how many of you are using Django as a backend? OK, most of the room. And how many of you are using Django REST Framework for APIs? OK, more or less half of the room, a bit more. OK. So the plan for this talk is the following. Let's create an API in synchronous Django REST Framework and replicate the same using a synchronous Django REST Framework. See what is working and what is not. As a man with little imagination, I've just chosen to create a demo based on the Django REST Framework tutorial, which is an application that implements a two model view set for the two Django contribute models, user and group. And in this application, each of these model view set has, of course, a model serializer. There is pagination. There is a default authentication and a router to handle the views URLs automatically. Sounds good. So let's try to implement the same in Async Django REST Framework. And now we get into troubles. So first problem I got is that the model view set are actually not implemented in Async Django REST Framework. Also the mixin that usually compose the view set in Django REST Framework are not already implemented. So anyway, no big deal. For the demo, I just wrote all the view set by hand. It's like 30 minutes of work. And of course, I have implemented all the mixin that compose the view set. Otherwise, it will take a lot more time. So you have just a big bunch of big mixin with a bunch of methods. And each of the model view set, like one for user, one for group model, inherit from this mixin. Next problem is that the HTML rendering of Django REST Framework API currently does not work in Async Django REST Framework. Again, not a problem. Like to input my data, I just use curl calling the endpoints directory, and I create the user and group instances from the Django shell. Then serializer, another problem is that actually related fields are not handled for asynchronous code. And so in the user serializer, I have serialization of the associated groups for the users. And so this is not working. Again, no big deal. I just remove the field from the serializer and move forward. Then there's no permission implemented by default in Async Django REST Framework. And so not a problem for this demo. So just I remove the authentication from my views. And then I gave up because quite a bit of problems. So jokes aside, I've tried to fix a couple of things I found like poking with Async Django REST Framework. For example, to decide if a view set is asynchronous or not, only the methods of the viewset class were checked. So since I implemented most of the helpers, of the sync helpers in a mixin, the code was thinking it was a synchronous class viewset. And so had to change that in order to run through the asynchronous code path. Then another problem in the API view class, sort of the same problem. Like it was reused the Django one, but is checking only the method named after the HTTP verbs. So like get, post, etc. Unfortunately, the view sets doesn't implement these methods, but implement like the actions, like list, retrieve, destroy, etc., update, etc. And so again, we were going through the synchronous path. Said that, after fixing these issues, I guess, I opened up a request because I'm still not able to have green tests. And so I'm looking forward for the response from the project maintainer. You can check the pull requests. So my experience with Async Django REST framework is that today is missing too much stuff to think of using it in the production. Said that, if any of you want like to poke with a web framework or try to understand how things works in a synchronous world, I think it could be like a good opportunity to contribute and help with developing the missing bits. Now, I don't want to end this talk without an happy ending. And so I've asked myself, can I contribute something useful, like to having a fully asynchronous Django REST framework? And so, as I said before, support for asynchronous views in Django is not 100% complete. So to reuse some already available synchronous code, we're using a couple of helpers from the sgref sync module. Sgref is the package, sync is the module. They called async to sync and sync to async. And they usually, they just like permit to go from one word to the other. And so if you look at inside Django code, you'll see that some paths use these helpers to go like from asynchronous views to synchronous code and back. So, and I was wondering, I think it may be interesting to actually see how many times we use them and we go from one word to the other. So these days, I'm not working on Django backends anymore. I'm working on OpenTelemetry for Elastic. And if you don't know it yet, OpenTelemetry is a specification implementation of telemetry system to enable observability for your services. So I thought on writing what is called in OpenTelemetry terms an instrumentation. That is some code that tracks some other code and set the telemetry again of the user of this code to a system. And so in this specific case, I've created an instrumentation to track how many times, and also to provide the stack trace of the, like to find out where the code paths are that are going from async to async and the other way around. It's not something I suggest to run in production, but I think it's fun to run. So, demo time. Before I start the demo, I show you a little example on that use OpenTelemetry auto instrumentation. That is an instrumentation that does not require you to change your code, but you instrument code from the outside. So we'll use OpenTelemetry instrument. That is the tool that permits this auto instrumentation. And we'll just instrument the async version of the demo of the Django REST framework tutorial. You see traces not sent to a real server, but on the console just for demo purposes. The demo recorded, but I can run it online if I need to. I'm sorry, I cannot increase the font, but I'll try to explain it. So we are calling, the volume. We're calling Open Telemetry instrument. We're just sending the traces to the console, and we are calling gunicorn that is running with a worker and using a uvicorn as a worker class. And other than that, we are passing just the ASCII entry point to gunicorn. And so I guess also the lights doesn't help. Anyway, this is in OpenTelemetry terms a span. That is a unit of work. And what the interesting bits are this one. That is the stack trace. You can see from the stack trace, maybe I can highlight that, but it's really small. And we see that it's in the code path of the middlewares. So load middleware is calling, I guess, some helpers that are calling sync to async. Other than that, I don't want to go into OpenTelemetry technicalities. But this is just from loading our application and not calling any request. And that was the demo. So hopefully I'm able to go back. Oh. Okay. So, to conclude, my impression is that in these last years, we only worried about the Django asynchronous support, and we mostly forget about all the ecosystem around, especially the Django REST Framework 1. So, there's still work to do to get an asynchronous version of Django REST Framework. And I usually did the project called Async Django REST Framework because the most advanced solution I found that is compatible with Django REST Framework. If there are others, I blame the search engines. Other than that, again, it's not only a problem in the Django REST Framework ecosystem, because a lot of the batteries that made like the Django ecosystem so great to work with are missing asynchronous support. And so I guess this is the right moment in time to play with the asynchronous support and maybe like try to contribute to fix any issues you get using external packages. I left on the slide a couple of references. First one is the wiki page from the Django documentation, then the discussion from the Django REST Framework forum, then a link to the Async DRF project. DRF is Django REST Framework. The link to the demo project on GitHub, a link to the OpenTelemetry project, and last one is the link to the instrumentation I wrote for tracking ASCII-ref. That's it. Thank you. Glad you take any question.
Great talk. I think we have some time at hand, so if you have any questions, just raise your hand.
Hi, thanks for the presentation. And my question is that is not included in your presentation, but maybe you will tell me. Did you notice the impact on the database when you switch to the async? Any performance across to the database connection, queries, etc.?
So the question is I found any database penalty, any performance penalty in that database path? Okay. I have to say I've just done this work as more for visibility of the issues than any performance benchmarking. And so for sure, the database path, the one that has still synchronous code. So, like, this doesn't really mean it will be slower. But this only means that it's not like the best possible performance you can get of the database. Say that I don't think that will be like the biggest issue. Yeah.
Did you found any issues during the transition to the async? During that transition from sync to async, right? Did you found any problems related to the connecting to the database, making queries or something like that?
Thank you. So the question was like if I found any issues, problem like doing the conversion from sync to async. Nope, I haven't found any.
Any more questions?
So the last thing that you mentioned, that you didn't see any problem switching between sync and async. I saw that you were counting the number of times that you are doing it, but did you try also to measure the overhead of switching between these threads of sync and async?
So the question is if I found any, I measured the overhead information from sync to async the other way around. No, I didn't measure that, but I think that will be, I wouldn't say pointless, but it's like our current state of things. It just, you have to accept that you have this overhead. And so I guess the most interesting part will be like doing benchmarking from from the user point of view. So latency or maybe some metrics on your machine, like memory savings or like being able to serve more requests with the same resources, stuff like that. Because like benchmarking internals like that, you can't act on that. You only take into account. So if it was me, like I'll just measure the end-to-end performance of the service, like from my user point of view. Thank you.
More questions? Okay, I think then we are done. Thank you, everyone. We'll meet again at 3:25. Hello, everyone. So we have Jill here. She will help us manage the data. And just a quick note, there will not be a Q&A, but you can ask her later after the session.
Thank you. So hi, everyone. My name is Jill Cates, and I'm a data scientist at Shopify, where I get to work on all sorts of interesting data problems in the e-commerce space. My favorite language is Python, by far, because I feel like as a data scientist, it offers so many great tools to work with data. One of the biggest challenges with Python, though, is that it's very challenging handling large data. And that's the reason why I put together this talk. So my goal in the next 45 minutes is to provide you with some tips on how to optimize your data, specifically using pandas, and also give you some ideas for other tools that you can use for handling large data. So before we get started, I think it's very important that we define the scope, because large data can mean very different things to different people. For example, data can come in many different forms. It can come in tabular data frames, it can come in the format of images, multi-dimensional arrays, time series data, audio and video signals, as well as graphical structures. For today, we are going to focus solely on tabular data frames. And by tabular data frame, I mean a two-dimensional structure where the columns represent attributes or features, and the rows represent samples in your data set. Another important thing to consider is the fact that data can have two possible states. So we have data in motion and data in rest. If we take a step back and look at the entire data pipeline end to end, you'll see that that pipeline consists of many different steps, from data acquisition to data transformation to machine learning modeling and data analysis. Data in motion represents the data transformation step, so ETL. And that can either be batch or streaming processed. Data at rest, on the other hand, is data that you would query from a table in a database in your data warehouse, or from a static file like CSVs, Excel files, and so on and so forth. So data at rest is primarily used one good use case for data at rest is exploratory data analysis. So this will be the focus of our presentation today. And lastly, what kind of system are we going to be working with? So data operations can happen on two types of systems. It can happen on a single node system, or it can happen on a distributed system. So a single node system is anytime you run analysis on your local machine. This machine is a single node system. When you want to work with much, much larger data, I'm talking terabytes, you can have multiple nodes or multiple you can have multiple computers working all together, which is ideal for running tasks in parallel. That being said, distributed systems have a very high overhead and can be expensive. So for today, we're going to be focusing just on single node systems. Okay, so I did a quick search for all of the Python packages that handle large data, and there are quite a few of them. In fact, I could spend hours talking about all of these. So the scope for today will just be the first three. We'll go over pandas, polars, and duckdb. So let's jump into pandas first. First of all, has anyone here heard of pandas? Raise your hand. Okay, quite a few people. Who here has used pandas? Okay, quite a few people. Well, I like to think of pandas as like the gateway package into data science. It's very established. It's been around since 2008 and was created by a guy named Wes McKinney. It's built around data frames and series data structures. And as you can see on the left, we have a data frame, which is a two-dimensional NumPy array behind the scenes. And on the right, we have a pandas series, which is a one-dimensional NumPy array behind the scenes. And you could think of a single column in a data frame being a pandas, it could be represented as a pandas series. So pandas, in my opinion, is a great option for manipulating and analyzing relatively small data sets. And by relatively small, I mean the rule of thumb here is that you should have 5 to 10 times as much RAM as the size of your data set. So my laptop here has 16 RAM, which means that I could probably handle 1 to 2 gigabytes of data. Pandas is also has a very, very strong community. It's well supported and works with many other libraries, including plotting libraries like Seaborn and Matplotlib, as well as machine learning and statistical modeling libraries like Scikit-learn and stats models. So let's just pretend that we want to do some data analysis on a relatively small data set that is 1 to 2 gigabytes large. I'm going to walk through 6 optimization tips to help you speed up your code. The first tip is to reduce your memory by only loading the columns that you care about. And this is especially effective if you're working with extremely wide data sets. So, for example, you might have a table with 100 columns, but you only care about 5 of them. In this case, you can load just the 5 using the useCalls argument within the pandas read CSV function. And as you can see, when I only load 3 columns out of 12 columns from this data set, I reduce the data frame size by 75%. Another good tip is to reduce your memory by specifying the column data types. Column data types affect your memory footprint, and this plot is a great example of that. So I went through the exercise of creating a NumPy array of 5,000 elements, each element having a value of 1, and I casted them into different data types. And so you can see here that on the left, an object data type takes a huge amount of space, whereas int8 or bool, very, very small. For those of you that haven't heard of the object data type, in pandas, this is used to represent string values as well as mixed data types. So it might have a mix of numbers and strings. So in this example, let's say you have a bunch of string columns. What you can do is actually cast them to categorical data types. So this is particularly useful when the column is actually a category and can only have a few possible values. And here I went through that exercise, and you can see that the data frame was reduced in size by 20%. Now, tip number 3 is actually very similar to tip number 2, but here I want to emphasize that it's really important to downcast your integers and floats. So by default, when you load data into your pandas data frame, it will automatically convert integers to int64 and floats to float64. But what you can do to reduce space is actually reduce the precision. So here I'm using float32, int8, and int16, and you can see that the size of the data frame is reduced by 40%. Now, let's say you forget what the range of each of these precisions are. I did find this really cool function offered by NumPy, where you could do numpy.info and numpy.finfo to remind yourself what the minimum and maximum values are for each of these precisions. Tip number 4 is to filter first before merging or aggregating. In Spark, we like to call this predicate pushdown. And what this basically means is you want to make your data frame as small as possible before doing any more complex operations on it. So in this example, when I filter first before aggregating, the speed it times to take to run the code goes from 123 milliseconds to just 58 milliseconds. So that's a 2-time speed up. Tip number 5, pretty obvious, well, for pandas users, but it is to avoid for loops at all costs. Pandas does have this thing called iter rows, and I strongly discourage you from using it. I do encourage you to use vectorized operations instead. And lastly, tip number 6 is to serialize your data. So most people, when they think of data, especially if you pull data from Kaggle, you'll see it in a CSV format. But if you have it in a Feather, Parquet, Pickle, HDF5 format, you'll see that the time it takes to read and write that data is much, much lower than CSV. So Pandas version 1 has really helped us get the job done for many data analysis use cases. But in 2017, the creator of Pandas, named Wes McKinney, wrote an article called Apache Arrow and the 10 Things I Hate About Pandas, where he basically complained about the package he created and mentioned all of its inefficiencies and talked about his vision for the future, which involves using Apache Arrow, a much more efficient memory format. And so his vision became a reality in 2023, just last year in April, which allows Pandas to have an Apache Arrow backend. This is very efficient. It's much better at supporting strings, much better at supporting missing values, and also offers zero copy data access, which basically means that it allows you to have efficient data transfer between systems. Now, if I wanted to use the PyArrow or Apache Arrow backend, all you have to do is specify dtype_backend equals PyArrow, and automatically you will be running a Pandas 2.0 data frame. If you take a look at the data types here, you can see that they look a little different than what you would see with NumPy. So on the right is the NumPy version, and you can see that float64 in NumPy world turns into a double in PyArrow world. Similarly, objects are now represented as strings. If you take a look at the performance, PyArrow as a backend outperforms NumPy. The first 3 rows here represent the data coming from an article called Pandas 2.0 and the Arrow Revolution by one of the Pandas maintainers, Mark Garcia. And you can see for all of these operations, the PyArrow backend is significantly faster. The last 2 rows are actually just a DIY benchmark test I did myself, and again, I did find that PyArrow is faster. It's especially more efficient when it comes to handling strings. So here you can see when you use a PyArrow backend and you want to apply the ends with operation, it is 31 times faster with PyArrow or Apache Arrow than NumPy. Okay, now let's move on to polars. Raise your hand if you've heard of polars. Oh, wow, okay, more people than I thought. Raise your hand if you've used polars. Okay, fewer people, that's good to know. Well, it makes sense because polars is a pretty new library. It was created in 2020 by Richie Vink, and similar to Pandas, it's built around data frames and series. It also uses Apache Arrow in the backend, but unlike Pandas, it's written in Rust and supports multi-threading. It also supports lazy evaluation and query optimization. And one of the coolest new features it has is a streaming API that allows for out-of-core memory processing. So I took a quick look at the polars resources out there. Even though it's only 4 years old, I found over 6 Python talks at conferences in the past year. So this just shows how rapidly popular it's becoming. Even though polars is built on data frames, though, it has a very different syntax than Pandas. So if you're used to Pandas, you might find polars a little harder to get used to. That being said, if you are used to PySpark, you will find polars to be such a pleasure because the syntax is very similar. You'll also notice that the data frame output looks very, very similar to Pandas. One nice thing that I like about this is that the data type of each column is shown right below the column name. Now, like I said before, Polar supports lazy evaluation. What this means is, well, eager evaluation means that your code is evaluated as soon as you run the code. But with lazy evaluation, each line of code is added to this query plan rather than being evaluated straight away. If you look at these 2 chunks of code, they look super, super similar. The only differences are that the top line you have scan CSV instead of read CSV, and at the very bottom you apply a method called collect. Despite the similarities, you can see that polars or the lazy evaluation way is much faster to run than eager evaluation. Looking a little deeper, you can see that polars has this concept called lazy frames, and behind the scenes, the query is actually optimized. So you don't have to worry about manually filtering before aggregating. Polars does all of that for you behind the scenes. Once you're ready to actually materialize your lazy frame into a data frame, you apply the collect method at the end. And also, let's say you have a data frame, but you want to convert it to a lazy frame, you can just pass it into a lazy frame class. Okay, the last feature that I want to talk about with Polars is the streaming API. And I think this is pretty powerful because it allows for larger than memory processing. What it does is it executes your query in batches instead of doing it all at once. And the only difference between the streaming API versus the non-streaming API is you pass in streaming equals true into your collect method. So this new feature is still in active development. It doesn't have all of the operations supported as streaming, but I still think it's a pretty cool feature. Okay, last but not least, DuckDB. Raise your hand if you've heard of DuckDB. Okay, and if you've used DuckDB? Okay, I think I see 3 hands. This is really great because you'll learn more about it. DuckDB is an in-process OLAP database. It was created 5 years ago in 2019 by Mulheisen and Rasfelt, and it's written in C++. Beyond just Python, it has client APIs in several other languages, including R, Julia, Node, many others. And what it does is it uses a columnar vectorized SQL query processing engine. Just like Polars, it does query optimization behind the scenes, and it also is interoperable with Apache Arrow. Now, in my opinion, DuckDB is great for SQL enthusiasts. As you can see here, I'm reading in a CSV file, and I can query that CSV file directly in my Jupyter Notebook, which I think is pretty cool. The output of this operation, or the output of this code, will give me something that looks like a table you would get from a database. One thing to note, though, is that it uses general purpose data types. So floats are represented as double, and strings are represented as varchar, just in case no one has dealt with SQL data types before. So DuckDB uses PostgreSQL syntax specifically, which comes with a whole range of different functions that you can use. And if you take a look here, the output of this code is actually a DuckDB Py relation, which means that it is a symbolic representation of a SQL query. It doesn't store any of the data, but when you run it, you can actually render the output of the query. Let's say you actually do want to create a plot out of this. You need to convert it to a data frame, but it's very easy to do. All you have to do is add 2df at the end of this code, and it will convert your SQL query into a pandas data frame. Likewise, you can do something very similar with Polars, where you just add .pl at the end. So this allows you to do all of your modeling or querying in DuckDB, convert it to a data frame, and then you can build beautiful plots with pandas or Polars. This is probably one of my favorite, most mind-blowing features of DuckDB. It allows you to reference variables in SQL queries. So when I first found out about this, I was like, wow, this is incredible. You can store intermediate queries as variables and reference them in other queries. So what I'm doing here is I'm creating this query called aggregated by state, which is doing an aggregation. And then in another query, I'm actually referencing aggregated by state, and it returns the data that I'm looking for. In addition to that, DuckDB also has a thing called Python UDFs, which are also known as user-defined functions. And what that does is it allows you to create a Python function and use that within your SQL query. So this is especially useful for situations where maybe you want to apply some sort of function onto your data, but there's no SQL equivalent function available. You can create your own custom Python function, and there you go. All right, now we can do a side-by-side comparison of all three. First, I was kind of curious about the downloads. If you take a look at all of these charts, it's pretty interesting to look at the downloads by continent. Pandas and DuckDB are primarily used among people in North America, whereas Polars, interestingly, has a pretty strong European user base. Also, if you take a look at the y-axes, you can see that Pandas has the most downloads by far, followed by Polars and DuckDB. And again, it makes sense that Pandas has a ton of downloads because it is the most mature. It's been around since 2008, whereas Polars and DuckDB have only been around since 2019 and 2020. You can also see that the latest version of Pandas is 2.2.2, whereas Polars and DuckDB haven't even reached their 1.0 release yet. I also found it interesting to look at the number of contributors. So Pandas has over 3,000 contributors, whereas Polars and DuckDB only have 400 and 300 respectively. That being said, Polars and DuckDB are actively maintained by very strong teams, and they've actually been turned into companies. In terms of features, we can see that Pandas is sort of lacking some of the features that you would see in Polars and DuckDB. For example, with Pandas, we don't get lazy evaluation, we don't get query optimization, and we also don't get multi-threading. However, you do have interoperability with PyArrow. So if whatever reason you want to use all three, it's very possible to do that. Now let's take a look at the performance. I personally have mixed feelings about benchmarking. I feel like benchmarking is just as much an art as it is a science, so proceed with caution and maybe take these results with a grain of salt. I did get these results, though, from the Polars website, where they did some benchmarking against DuckDB and Pandas. And you can see across all of these queries, Pandas is by far the slowest. Polars and DuckDB are comparable. In fact, in some cases, DuckDB is actually faster than Polars. I did my own very, very, very unofficial benchmarking where I took two operations that I usually do on the job, so aggregated count and aggregated mean, and I did find that Pandas was much slower. In fact, in one example, it took almost 45 seconds to run aggregated mean with Pandas, but Polars and DuckDB both under a second. Also, if you look at DuckDB, you can look at the performance in two ways. So the first way is if you just run the SQL query and have it represented as a DuckDB Py relation, it can run on the order of microseconds. If you want to materialize it, though, to an arrow object, Pandas data frame, Polars data frame, it does take a little bit more time, but again, it's still under 1 second, which I thought was pretty impressive. Okay, in summary, you might be wondering, which package is best? Well, just like a good data scientist, I'm going to tell you it really depends. Each of these packages, Pandas, Polars, DuckDB, they each have their advantages and disadvantages. But there are some things that you should consider when making a decision. For example, the size of your data, the learning curve and amount of spare time you have to learn a new syntax, as well as the knowledge base of the contributors and peer reviewers involved with your code. But really, my recommendation is that you should try them all. I do find that the documentation for all of these packages to be very, very comprehensive, and there are a ton of tutorials and resources around them. So on that note, thank you for listening to my talk. I hope you learned a little more about how to handle data with Python. And if you want a link to the slides, I put a little QR code there.
Again, we have some time, so if you have any questions, maybe just raise your hands.
You mentioned that to determine like when you might want to use one of these libraries, you had like a threshold of how much data you would consider a small amount of data. But would there be like another threshold for whether you should just use like native Python versus actually implementing Pandas or Polars in your workflow? Like what would be the upper bound there where you say, okay, you have enough data, maybe you should start using one of these other libraries to process your data?
That's a very good question. So just to confirm my understanding, the question is, why not just use native Python instead of one of these packages?
Well, like, would there be an upper bound where you would decide to make the switch versus native?
Got it. I would say one great thing about these packages is that it has all these operations created for you. If you were to do this with native Python, there would be a lot of work involved and a lot of effort to make it efficient behind the scenes. So in general, if you're working with tabular data, I would say avoid using native Python at all costs. That being said, if you work with other data types like images or audio signals, there might be a threshold. I'm just not as familiar with them.
I would like to know if there are many differences between Panda and Polars for what is about the use of RAM. Using the same amount of data, managing that by Panda or Polar, there is a huge difference in the use of RAM?
That's a good question. So if we were to run the the same code with pandas and polars, I do think the polars will be better, and that's only because it has this query optimization behind the scenes. With pandas, you don't have that. So with polars, when you do lazy evaluation, you don't need to care about the way that you run your data analysis. It will just do all the optimization behind the scenes.
There's one question from Slido. So it is, did you check the performances about the RAM usage?
Good question. I did not.
Oh, okay. Who's next?
Thank you very much for the talk. In your very, how do you say, unprofessional benchmark you did on your own, have you used high performance pandas? This is using the methods query or eval, or EVAL, how do you pronounce it?
Eval.
Eval. And there you can write the statements as a string. They look more or less like SQL. Have you tried this, or have you chained methods? Because I heard that high performance pandas does a pre-compilation of the statements, it does the optimization, and then it's high performant, as the name says.
Got it. Just to confirm, the question is whether I use the query method. So the answer is I didn't, but that's because I didn't do any filtering. Querying is often used for filter operations, but in this case, I just did a group by and I counted. I do think the query operation is faster, though, than the other types of ways of filtering. But from my understanding, it's only efficient if you have a certain size of data, if that makes sense. There's a threshold where if you have at least 500 megabytes, then the query method is actually more performant. But I've heard that very, very small data sets, 1 megabyte, the other way is better.
More questions?
You mentioned for pandas that the rule of thumb is that you need a RAM of 5 to 10 times the data set. Then that's more or less the limit. What's the limit for polars or DuckDB? Did you hit it? Or?
Good question. I don't know if there is a rule of thumb for polars or DuckDB. That rule of thumb that I said for pandas, that was actually provided by the creator of pandas. But I'm not sure what the limits are for polars and DuckDB. That being said, there is a company called Coiled that is the maintainer of a package called Dask, and they did a bunch of benchmarking tests and found that when you work with 1 terabyte or 10 terabytes of data, oftentimes polars will fail, and sometimes DuckDB will also fail. So I would say maybe 1 terabyte or larger, not a good idea to use these packages.
So apart from the Polar streaming API, when you have a data set that is too large to fit in your available memory. Have you come across any other approaches to deal with that?
That's a good question. For me personally, when I'm on the job, if I do have very, very large data that is out of memory, I would often go for the distributed system route. But in terms of data analysis, I would say Polars is like one of the first examples where you can do out-of-core processing. You can also do out-of-core processing with DuckDB as well.
More questions?
If I'm right, you said that using Apache Arrow as backend, Pandas is faster. So why is not default now? If it is faster using Apache Arrow as backend in place of NumPy.
I see.
Yeah.
Very good question. So I also wondered this. I thought, well, why doesn't everyone just convert their NumPy data frames to PyArrow or Apache Arrow? And I learned that it's not completely backwards compatible yet. So there are some operations that are offered in Pandas v1 that aren't working so well in v2. But I have heard, because I was at PyCon US just last week, they were talking about a Pandas 3.0 release, and that should be backwards compatible. So we're almost there.
More questions?
So one question. Thank you for your talk. So in Pandas, we usually use GeoPandas library to manage geographic data. Is it possible to do it in Polars?
Good question. I'm not so familiar with GeoPandas. It might be possible. You would have to check. But if it's not possible, what you can do, if you have a very, very large data frame, you could process it and make it smaller using Polars or DuckDB, and then convert it to a Pandas data frame, which you can then pass into GeoPandas. And I think that's one of Pandas' greatest strengths. It just has such a strong community and so many packages that are built around it. I don't think that we're quite there yet with Polars or DuckDB.
I've seen that Polars, to use Polars with PyArrows, you have to install it with the PyArrows extras, so with the square brackets. So I've not verified this. But do you know whether, if you install Polars without the PyArrows extras, will it not use PyArrows?
Good question. I did pip install Polars without the brackets, and it worked. Apache Arrow is the default for Polars in the backend, so I think it's like an absolute requirement, and it should work.
More questions? Anyone?
I was wondering about, like, when managing more than terabytes, maybe petabytes of data, how can you manage a complete analysis? Like, do you sample? Also, maybe, I don't know, if Shopify does consulting for other big techs, but like, do you sample maybe data? And if so, how do you sample it to analysis?
Ooh, I like this question. I mean, it would be really amazing if there was a world where you could do data analysis on a petabyte of data. I don't think we're quite there yet, but you're exactly right. We would want to do some sampling, and I think it really depends on what the question is. So in the context of Shopify, if a question was around wanting to know the sales among merchants in a specific country, I would filter for shops in that country and do some sampling there. It's really context heavy, context dependent.
Questions?
I think one important thing to specify is that when working with floating point data, maybe the range is important, of course, but also the precision. So maybe you are not allowed to use float 32 because you need more precision for the calculations. So.
Yeah. That's a very good point. I should have actually went back to the slide that I was sharing earlier. Maybe I'll just try doing that now. There is that table that I showed from NumPy finfo and iinfo. If you take a look at the ranges, that will give you a sense of what kind of precision you can work with. Actually, my computer's frozen. But yeah, you'd want to know what the ranges are of your column, and then you can determine the appropriate precision.
Okay. And another question is about the benchmarks that you run. It's about the last data for DuckDB. Why is so fast with the last? Because my understanding is not using PyArrow. It's using some internal format for achieving these around microsecond values. It's really strange, because the other ones are more or less not comparable, and that's just not 3 order of magnitude better.
Yeah, I think that my result might be a little bit deceiving just because the microsecond result is coming from a situation where I'm just running the query and not storing it anywhere. So it's not like, so let's say I run a query and the output is actually like 100,000 rows. It's not storing it anywhere, it's just rendering like the first X number of rows. But if you're dealing with a query where you only want to inspect the first 5 rows, it's really cool that you can run this and it takes microseconds. And then if you are ready to materialize it into a data frame, you can easily do that using the 2df or the .py method.
More questions? So I guess we are finally done. Thank you for a wonderful talk.
Thank you.
And his topic is on building easy interactive apps.
Thank you very much. Now I'm talking about two libraries, Streamlit and Gradio, which to pick. And spoiler alert, the answer will be yes. Now, I will give a little introduction to Gradio and Streamlit, and three different use cases on the perspective of a backend developer, data analyst, machine learning data scientist, and drag some conclusion, and there's so much awaited answer to the question. You can check out these slides, are available online if you want to follow with your mobile phone or so. Let's go on. Now, Streamlit and Gradio are two Python packages which are designed to create some simple web apps with low effort or relative low effort mode. It means that you can create some web app with just a bunch of lines of code. Too fast. You can use either of them to create a simple interface for presenting your work to your coworkers which do not code, or to your customers as well. Because the situation, for instance, in my work experience is that you present something to the PM and you just present the code and the execution, and he has no clue or where to look. What I'm seeing now. But when you show a web app with the very same stuff, oh, here it is. I know this is the result. This is what I wanted. So this is just a way to focus on the code work instead of what comes before and what is more important to us. And let's do the rest of the work. Let's look at the home pages. Streamlit introduces itself as a faster way to build and share data apps. In a very similar manner, Gradio introduces itself like build and share machine learning app. So build and share is common between the two, while Gradio just focuses on the machine learning perspective. There are many common features. Both of them are run by a company. Streamlit has its own Streamlit company and cloud service, while Gradio is on Hugging Face. On both of them, you can give multimedia input and outputs, like text, image, video, audio, or any binary file you can imagine. There are customizable buttons, sliders, and filters you can use, and you can display outputs in multimedia, but also in other formats like pandas data frame, some charts, some graph, and some chat-like text that can appear all of a sudden. Both of web apps can be published to respective platforms and hosted for free with limitation, of course. There are some differences. Well, Gradio introduces itself as a machine learning stuff, so it's input and output by default. So the default and simplest use of it is you have a box for the input and a box for the outputs, while Streamlit is not falsely so. Functions are the triggers for Gradio, while Streamlit is script-based. So you just execute a script in a sequence. So by consequences on Gradio, the operation sequence is defined by user. So you can place your button wherever you like, but it does the very same function that you defined. While on Streamlit, by default, again, the operation sequence is from the top to the bottom of the page you're creating. A function runs or reruns as you click the button, and never again. And in Streamlit, to the other side, all operations run by default in a script manner. And they rerun as one element that went before change. So I have one filter at the top and the graph at the bottom. Say, if I change the filter, the rest of the script will execute again and the graph will change. The Gradio has by default, again, a rigid block structures, and Streamlit has no such rigid structure, as all actions are defined at least in the default manner. So, first story. Suppose you're a backend developer and you have to show any Python function or service you wrote. I put in a very simple hello world like service on Flask. So you just call the method get on slash, so on the home of the service. And if you have your name in the arguments, it will print hello name. And if you don't print anything, it's hello known. Let's present it. The way to run a Flask app, of course, is the same as always. So Flask app, name of the Python file run, and the host and the port. On Streamlit, this is a way to recall that service, that microservice, of course. And with the name has the only input that I want. Let's take st.text input. So I'm asking the user to write the name. And if it writes the name, just write what the service returns. Let's see it in action. Of course, the way to run a Streamlit is just Streamlit run and the name of the app. Pretty straightforward and easy. Now let's see it in action. Should be autoplaning. Okay, this is the Flask service. I'm making it run, and it's running right now. Let's move to another. I'm doing a Streamlit run, and it opens a browser where I'm asked for the name. My name is Davide. Hello, Davide. But I can say that to Moto, and so it's hello, Moto. Yeah, I'm that old. Now, let's make the very same thing, but with Gradio. Well, the function is the same as before. You just define the interface, and that will be the very core function in a very hello world-ish of hello world of Gradio. Now, the function will be hello, so it always have to run by a function, if you recall, and to define the inputs and the outputs in its format, so text and text. So I will have a text in input and a text as the output, and the trigger will be the function hello. Let's see it in action. As you can see, there are separate blocks created by just those lines of code, and I have to click on the submit to have the function executed. And again, I try to change the name, and a different name will be displayed. Second case scenario, suppose you're a data analyst and you have to write a report of the Titanic CSV dataset. Say you have to make a bar plot of survival radius and filter it by sex, age, and maybe class. Now, for those who don't know it, the Titanic dataset is the hello world of data analysis, and it's the very first one. People recall the movie when I watch it and work with it with the first time. I actually recall middle school flutes really out of pitches. In Italy, we were forced to play it, and it was awful. So I made a generated image with middle schoolers playing it as the Titanic was shipping, just to make a laugh about it. Let's go on. So this is the time for Streamlit to shine, because it's more made for data analysis. Let's make a title, Titanic dataset. I can read a CSV directly from the GitHub and put a divider just for doing nice thing. Let's make the filters. The filters are for class, sex, and ages. I put it on 3 different columns. So the calls with the index from now on will be the thing to call instead of st. So instead of st.multiselect, it will be call.multiselect. By is the p-class, sex, and age I am iteratively working on, and the option will be the unique values. So if not, the length of select is 0. I just filter the data set with that measure in that list that I specified, and put another divider and just write the data frame and chart. So st.barchart will make a bar chart, of course, and while st.write is the magic of Streamlit. So it takes pretty much everything in and just display. It is a pandas data frame. You will see a data frame in that case. Let's see it in action. This is what I get from this very code that I showed you. Suppose I filter by first class and female, and this is the result. It's pretty nice looking result for a few lines of code, in my opinion. From this, you get, as the movie taught us, that if you're a female in the first class, it's all right, while if you're a male on third class, better start your prayings. Let's try the very same thing with the Gradio package. So it's pretty similar. Initially, you have to define a filter function, which will be the trigger function. And this is the function that filters. It is similar to the previous one, but it does not have this for. Okay, let's make the interface. The function will be the filter. The inputs will be 2 drop-downs. Choose male, female, or first, second, third class. I did not filter by age this time. The output will be 2. In this case, 1 data frame and a bar plot of a data frame. If you look at the previous function, we have 2 data frames, and it's the very same object, but in this case I'm treating them differently. In one case it will be shown the data frame itself, and in a second case a bar plot of it. So you call demo.launch and just run this file, and this is what you get. So you just pick a gender and a class, and in the right pane you will have the data frame filtered, so only males in here, if I don't get wrong, and the survival rate as before. Okay. How I'm doing with the time? I think it's fine. Okay, I can go slower. Maybe I ran out a little too much. Suppose you're a machine learning data scientist and you have a model to show. Suppose just an image detector. You will have to pick some different image in your demo, and so the input image will change. There is indeed an hello world image for the computer vision stuff, which is Lina. But Lina herself told she didn't want to appear in more article and more scientific and more computer-related stuff. So I'm going to respect that. So the data in that case will be myself during another conference, and what I will from now on propose as a new default for computer vision, which is my own cat. Okay, my own cat had that teeth that came after her mouth. She was a very nice cat, despite her appearance, so you can trust her. But I was arguing with my aunt, this is not a cat, and I can prove it, and I will prove it. Let's see if she will categorize as a cat or not. I hope not. So, it's time for Gradio to shine. This is quite simple to do in Gradio. For doing the object classification, I just use a client, which is a Gradio client, Hugging Face one, sorry. And you get the file name from the input, and as an output, you got the image where you draw boxes on the result of the object detection. So you will see myself or the cat with boxes stating what it is. Demo.launch, and let's see the results. As always, I had to upload the cat.jpg cat and click submit, and it states that it's a cat, and it's pretty sure of it. I do not agree. But apparently my aunt was right according to this model. Now, let's get to Streamlit. This is a bit more complicated. As you can see, there's more lines of code. The object detect function is the very same one as before. Let's make a title, image detector. I have to upload the file, and you do it with st.fileuploader. And you choose the image file. And only if there is an uploaded file, he goes on. Recall, Streamlit is a script. So if you don't put if, this line of code will execute by default even if you don't have an image, and this will give error, of course. Now, let's take the name as before, call the object detect function, and display the image. I could use write, but this is an image, it's more proper. Check out the results. Okay, I had to drag on and upload the davide.jpg file, and he showed a laptop, a bottle, and a person, which apparently is, so I'm a normal human being. That's cool. So let's jump to the conclusions. Both packages have made recent advancement in which this division, Gradio for data, machine learning, Streamlit for data analysis, wants to get broken more and more. So you can think of building with them a more generic web app if you want. But still, Gradio is namely built around the data scientist need. So I will have just one function as a trigger, and that will be my input output, and that function will contain my machine learning model execution. Streamlit is possibly better for data analysis. Both are great for presenting to colleagues any overcomplicated code that you made, focusing on the functionalities and hiding the implementation details. Both of them have a great learning curve. You can start with a very few lines of code, the one that I present you today. If you want to check out the video or the slides again, you can. And this will give you fully functional stuff. But you just want to learn more and more of it. And as much as you use it, as much as you want to learn more. So it's pretty much another rabbit hole to follow. So thank you very much for listening. These are my contacts if you want to check up with me. Bye.
Thank you, David. So we have some time at hand. So do we have any questions? Sorry? Okay. Okay.
All good. I was just wondering, are there customization options for the charts, particularly in Gradio?
Yes, there are. In Gradio, you can display any image. So the easiest customization you can make is just plot as a matplotlib or wherever library you can use, save it as a file, and display the image file. That will be the easiest way to do customization for it.
Awesome. Thank you. And really good talk. Thank you.
Thank you very much. Too nice.
More questions?
Yeah, I generally use Streamlit, but I recently developed an application with Gradio because I needed smooth state management between different users, and I haven't tried with Streamlit. So if you know, if you can expand this point of state management, multi-users.
That's a very cool point. Thank you. Streamlit has some cache memory. So you can just memorize some function or data as well. So suppose you have one pandas data frame, say, or whatever, or the function or data of Python object that you can save for other purposes, you can. And so you can, Streamlit can divide the web app into pages. And a page is a different Python script, but you can take say from the home page. If the home page loads the data, you can save the data and just get it back for another script in another page. That's a very cool feature.
Questions?
Hello, thank you for your talk. Have you tried UI components in Streamlit and Gradio for chat interfaces? And also, have you tried other framework like Chainlit for building up chat interfaces? Thank you.
I did do some limited tries for building a chat like web app. It's not perfect yet, in my opinion, because it doesn't yet look a real chat with a real person. It seems a bit of a fake thing. In both Streamlit and Gradio in this moment, but my opinion. And no, I haven't tried any alternative, but thank you for your suggestion.
More questions? So I guess coffee break starts a little early. Thank you. Bye-bye.
That's the best part. I would like, they make me Power BI stuff. But if I get a cost, yeah, and managers like more.
And I think with Streamlit you can only have, like, the data needs to be stored in the browser, so you're like limited to the amount of data you can render.
Yep, but actually, if the data comes from a non-static source, say like a database that you can query, you can just set up a time for your memory storage. So after that time, if you reload the data again, or there are many ways to have buttons to reload data. As well as you reload data, you will have the novelties. So no problem in this side.
Cool. So, which do you prefer?
Between?
Radio versus
Streamlit is a little bit more out-of-the-box stuff. So you can place things pretty much wherever you want, only remembering the execution from top to bottom.
And it got acquired by Snowflake.
Sorry?
It got acquired by Snowflake, so it's pretty well supported.
Yeah, and you can host for free, at least out now. That's good. I had a customer with almost zero budget. Apart from paying me, they had no money to spend on anything. Okay, that's the solution.
Yeah. Actually, have you heard of Shiny, like in our world?
Yep.